The news struck the world like a thunderclap. In the vast stillness of the universe, where distances are measured in millions of miles and time is marked by eons, a new urgency now rippled through the scientific community. The James Webb Space Telescope, humanity's most powerful eye in the cosmos, had just confirmed something almost inconceivable. A massive interstellar object, designated 3I Atlas, was no longer just passing through our solar system. It was on a direct collision course with Mars. Before we start, hit the like and subscribe buttons for more exclusive news. For months, astronomers had been tracking 3I Atlas with cautious fascination. Initially, it was thought to be another fleeting visitor from beyond the solar neighborhood, much like the earlier interstellar travelers Oumuamua and 2I/Borisov. But as the Webb telescope refined its data, observing the object in multiple infrared wavelengths with unmatched precision, patterns began to emerge that told a different, far more dramatic story. The object's trajectory was subtly shifting, its velocity deviating from the predictions of gravitational modeling alone. Something was influencing its path, perhaps outgassing, perhaps gravitational interactions, and then the models converged. Its new course intersected squarely with Mars's orbit. The confirmation set off an unprecedented wave of analysis and speculation. The Webb telescope, orbiting far from the interference of Earth's atmosphere, had achieved what no previous instrument could: a precise measurement of the object's composition, reflectivity, and thermal behavior. 3I Atlas was not merely a lump of rock and ice. It exhibited characteristics more akin to a composite interstellar fragment, a mix of volatile-rich material and metallic inclusions forged in the debris of another solar system's collapse. Its surface glinted with a unique spectrum of light, hinting at exotic minerals never before cataloged. To planetary scientists, it was an irresistible enigma. To mission planners and astronomers, it was suddenly a celestial bullet with Mars in its sights. Mars, the quiet red planet that had inspired centuries of exploration dreams, now stood at the center of a cosmic drama. The impact, if unaltered, was projected to occur within a few months, a blink of an eye on astronomical timescales. The collision would not be a minor event. Even though 3I Atlas measured only a few kilometers across, its speed relative to Mars was staggering. Tens of kilometers per second, far greater than the velocity of typical asteroids native to our solar system. The kinetic energy unleashed upon impact would rival the most devastating natural events in planetary history, capable of reshaping terrain, melting crustal layers, and potentially sending shockwaves through Mars's tenuous atmosphere that could be detected even from Earth. The first reactions among scientists were a blend of awe and disbelief. The James Webb Telescope had been peering into the depths of the early universe, uncovering galaxies formed mere hundreds of millions of years after the Big Bang. Yet now its instruments were focused much closer to home, capturing the fate of a neighbor world. Teams at NASA, ESA, and observatories worldwide convened emergency sessions, sharing raw data and refining trajectory models with every new set of readings. Deep space tracking stations confirmed Webb's observations. 3I Atlas was indeed on a collision path, with an impact window calculated to within a few hundred kilometers. The margin for error was shrinking fast. The discovery ignited a cascade of new questions. How had an object from another star system come to be ensnared in such a fateful encounter with Mars? Interstellar objects typically pass through the solar system on hyperbolic trajectories, barely grazing the sun's gravitational influence before being flung back into the galactic dark. For 3I Atlas to end up bound within the inner solar system required extraordinary circumstances. Perhaps it had been slowed by interactions with the outer planets. Jupiter's immense gravity could have played a role, bending its path inward. Or maybe outgassing jets from volatile materials sublimating under solar heating had altered its motion, a self-propelled cosmic drift that slowly nudged it into a deadly orbit. As the world absorbed the news, Mars-based missions became the focus of renewed scrutiny. The orbiters circling the red planet, NASA's MAVEN, the European Space Agency's ExoMars Trace Gas Orbiter, and even older relics like Mars Odyssey were suddenly tasked with monitoring a phenomenon of existential magnitude. Every instrument, every camera, every sensor capable of tracking atmospheric and geological changes was turned toward prediction and observation. Robotic rovers like Perseverance and Curiosity, still active on the surface, would serve as unwitting witnesses to a moment that could redefine planetary science. In the control rooms of space agencies, tension mingled with a strange exhilaration. The collision presented an unparalleled scientific opportunity, the chance to directly observe the impact of an interstellar body on a terrestrial planet. The data could answer questions long debated about the chemistry of other star systems and the role of such objects in seeding planets with complex molecules. Yet the potential destruction was staggering. The point of impact was projected to lie somewhere between Mars's equatorial regions and its southern hemisphere, a zone rich in ancient geological formations and sedimentary layers. The energy released could excavate a crater hundreds of kilometers wide, exposing strata that had been buried for billions of years. For the scientific community, the prospect was both catastrophic and profoundly illuminating. The James Webb Telescope's confirmation came after weeks of quiet verification. Its near-infrared spectrograph had been observing the faint cold glow of 3I Atlas from a distance of hundreds of millions of kilometers. Unlike the Hubble or ground-based telescopes, Webb could pierce the object's dusty coma, revealing subtle temperature fluctuations across its surface. These readings suggested active outgassing, a hint that volatile compounds like carbon monoxide and water ice were vaporizing as sunlight struck its surface. That activity, though minute, could have been enough to shift its trajectory over time, altering its path toward Mars. The implications were breathtaking. The same physical processes that shaped comets and asteroids in our own solar system were at work in this interstellar wanderer. But their combined effect had produced an outcome with planetary consequences. The confirmation sent ripple effects through every branch of space research. Astrobiologists pondered the potential of interstellar material colliding with Mars, a planet already considered one of the most promising hosts for ancient microbial life. If 3I Atlas carried organic compounds formed in the interstellar medium, complex hydrocarbons or amino acid precursors, the impact could theoretically deposit alien chemistry onto Martian soil. Conversely, it might vaporize any trace of existing Martian biosignatures, erasing geological records before future missions could study them. The cosmic irony was not lost on anyone. Just as humanity prepared to send the next generation of exploration missions to Mars, including sample return projects, an object from beyond the stars was preparing to rewrite the planet's surface. Within the deep corridors of NASA's Jet Propulsion Laboratory, mission engineers and orbital analysts worked around the clock to model possible outcomes. They simulated the shockwaves, ejecta dispersal, and potential for material to escape Mars's gravity. Some projections suggested fragments could enter orbit around the planet, forming temporary rings of debris that might persist for years. Others predicted a more direct plunge of ejecta toward the Sun, a fiery epilogue to the cosmic event. Still others speculated that small fragments could cross the gap to Earth's orbit, though the probability remained vanishingly small. Each model added a new layer of understanding to the unfolding scenario, and with every new data set from Webb, the precision increased. The telescope itself became a symbol of humankind's strange position in the universe, capable of perceiving events millions of light years away, yet now bearing witness to an impending catastrophe in its own celestial backyard. Engineers at the Space Telescope Science Institute optimized Webb's observation schedule, alternating between deep space targets and continuous monitoring of 3I Atlas. Its powerful instruments, designed to study the faintest galaxies and distant exoplanets, now track the spectral heartbeat of a tumbling rock hurtling toward Mars. Every shift in brightness, every flicker of reflection was cataloged. The data streams were immense, yet each byte held potential clues about the object's density, rotation, and internal structure. Meanwhile, planetary defense teams found themselves in uncharted territory. Their protocols were designed to protect Earth, not another planet. Deflection strategies, even if theoretically applicable, were unfeasible at such interplanetary distances and on such short notice. The question was not how to stop the collision, but how to observe and learn from it. Proposals flooded in. Send rapid response probes to monitor the event, position existing spacecraft to capture high-speed imaging, coordinate with Mars rovers to record ground-level data. Every option was considered. The collision might be a disaster for Mars, but it was also a once-in-a-civilization scientific opportunity. As astronomers mapped the trajectory, they noted how eerily precise the alignment was. The impact path cut through Mars's orbit almost perfectly, with the planet arriving at the intersection point within hours of 3I, Atlas's projected arrival. The chances of such synchronization were infinitesimal. Some scientists whispered about gravitational coincidences, others about the subtle orchestration of orbital mechanics that had been centuries in the making. Nature's timing, it seemed, was both indifferent and extraordinary. The details of the object's composition fascinated mineralogists and spectroscopists alike. Webb's spectral data revealed signatures of metallic silicates interspersed with compounds of carbon and nitrogen. These were not typical of our solar system's asteroid belt. They hinted at origins around a different kind of star, perhaps one rich in heavier elements, an ancient system where planets had long ago disintegrated under tidal stresses. 3I Atlas, then, was a fragment of another world entirely, a shard of alien geology flung across interstellar space, now destined to merge with a planet that had once been the cradle of Earth's greatest scientific curiosity. The implications extended far beyond Mars. If interstellar bodies could be captured or collide with planets in the inner solar system, then the exchange of material between star systems might be more common than previously believed. Panspermia, the idea that life's building blocks could travel between worlds, gained new traction. Perhaps early Earth had been seeded by such encounters, its chemistry enriched by fragments like 3I Atlas. Now humanity had a front-row seat to witness such a process in action, not as theory, but as cosmic reality. The astronomical community buzzed with anticipation as more observatories joined the effort. The Vera Rubin Observatory in Chile tracked the object's visible light curve, while the ALMA array in the Atacama Desert scanned for radio emissions from its ionized gases. The combined data painted a portrait of a dynamic, tumbling body venting streams of volatile material as it approached the sun. Its tail, barely visible in optical wavelengths, stretched for thousands of kilometers, a ghostly reminder of its alien origin. Mars, for its part, glowed faintly in infrared images, an orb of iron and dust awaiting its fateful encounter. Public fascination grew just as rapidly. Renderings of the projected impact spread across news outlets and social media. An incandescent streak across Mars's skies, a plume of debris rising hundreds of kilometers above the surface, a shockwave that would ripple through the thin atmosphere. Humanity had always been captivated by cosmic events, the death of stars, the dance of comets, but this was different. This was tangible, immediate, and visible within our own solar system. Even though no human stood on Mars to witness it, robotic eyes and telescopic lenses would soon transmit the story in real time. For those who had spent their lives studying planetary impacts, the event represented a natural laboratory beyond any dream. Impact cratering is one of the most fundamental geological processes in the solar system, shaping moons, planets, and even influencing atmospheres. Yet never before had scientists been able to predict such a massive impact in advance, let alone with an interstellar object. The data gathered would allow researchers to study not only the physics of the collision, but also the chemistry of the interaction between alien material and Martian minerals. The aftermath would be a canvas of raw planetary transformation, a reminder of how violence and creation coexist in the cosmos. Deep within the James Webb Telescope's data archives, new revelations continued to emerge. The thermal emission from 3I Atlas showed oscillations that suggested it was rotating unevenly, perhaps tumbling chaotically. That instability could mean the object was fractured internally, a conglomerate of smaller pieces loosely held together by gravity. If so, the impact might produce multiple secondary collisions, as fragments dispersed upon entry into Mars's atmosphere. The possibility of atmospheric fireballs and simultaneous surface strikes added complexity to every simulation. The scientific community raced to refine its models, each iteration bringing humanity closer to understanding the choreography of destruction about to unfold. As days passed, a strange calm settled over the narrative. The inevitability of the event became accepted. There was no intervention possible, no redirection that could alter the course of a celestial visitor traveling at tens of thousands of kilometers per hour. What remained was observation, and through observation, understanding. The James Webb Telescope continued to serve as the sentinel, its sensors capturing every faint photon emitted from the approaching interstellar body. On Earth, supercomputers rendered the impact scenarios in vivid detail, simulating the fiery descent, the moment of contact, the rise of the ejecta cloud, and the gradual settling of dust that would follow. The collision's predicted effects on Mars's atmosphere were staggering. Despite its thinness, the atmosphere would briefly flare with incandescent energy, generating winds exceeding hundreds of kilometers per hour in localized regions. Dust would billow into the upper layers, potentially encircling the planet in a haze that could persist for months. For orbiters, this posed both a challenge and an opportunity. Solar panels might be affected by reduced sunlight, but the chance to study the dynamics of dust and gas distribution from such a cataclysm was irresistible. The instruments aboard the orbiters were reprogrammed for high-frequency data collection, ensuring not a moment would be missed. Every telescope on Earth turned toward Mars in preparation. Even amateur astronomers took part, contributing their small but invaluable observations to a global database. The collaboration between professionals and enthusiasts mirrored humanity's collective awe before the vastness of space. The knowledge that an interstellar traveler was about to strike another world united scientists and dreamers alike, transcending borders and languages. It was a reminder that the universe is not distant or detached. It is a living system of motion and change, of collision and creation. The night before the projected impact, the James Webb Telescope captured its most haunting image yet. Against the black tapestry of space, Mars gleamed faintly red, and in the distance, a tiny shimmering point. 3I Atlas approached, glowing faintly with reflected sunlight. The image symbolized both fragility and inevitability, two worlds drawn together by the invisible hand of gravity, a dance billions of years in the making, soon to culminate in fire and dust. Scientists around the world awaited the culmination with a mixture of dread and exhilaration. The impact would be detected first in the infrared spectrum as a burst of heat, followed by visual confirmation from orbiters and telescopes. Instruments aboard Mars orbiters were synchronized to capture the moment of contact at millisecond precision. The James Webb Telescope, stationed far beyond the Moon's orbit, would record the thermal bloom as it expanded across Mars's surface, its sensors straining to capture the wavefront of light from a collision happening millions of kilometers away. The very fact that humanity could anticipate such an event marked a triumph of technology and knowledge. The Webb Telescope, built to peer into cosmic history, now bore witness to an unfolding chapter of the solar system's ongoing evolution. It had extended human perception to the edge of the possible, linking the ancient and the immediate in one continuous vision. From the first faint detection of 3I, Atlas's motion to the precise mapping of its descent toward Mars, the telescope had transformed mystery into understanding. The silence before impact carried an almost spiritual weight across the entire scientific world. Though separated by millions of kilometers, the consciousness of humankind seemed to converge on that single red point suspended in the blackness, a planet on the brink of transformation. In observatories from Hawaii to South Africa, in mission control centers humming with quiet intensity, the countdown to collision was measured not in minutes, but in heartbeats. The James Webb Telescope continued its relentless vigil, its instruments tuned to catch the last rays reflected off the tumbling interstellar object. Even in its final approach, 3I Atlas defied easy categorization. Its light curve fluctuated with eerie rhythm, as if it were flickering between identities, a wandering relic of an alien system preparing to merge with a world of our own. Scientists who had devoted their lives to studying planetary evolution found themselves on the edge of revelation. The event promised to reveal in minutes what might otherwise take centuries of research to infer. The high-resolution spectrographs aboard Webb and other observatories would soon capture the spectral fingerprint of the impact's incandescent plume, allowing them to analyze vaporized material from both the object and the Martian crust. The very chemistry of an interstellar traveler and a planetary body would be exposed in one cataclysmic burst. Somewhere within that data, buried in the wavelengths of scattered light, might lie answers to the oldest cosmic questions. How matter migrates between stars, how elements are recycled across galaxies, and perhaps even how life's fundamental ingredients are shared from one system to another. Mars itself loomed in those last hours like a waiting witness to its own fate. Its thin atmosphere shimmered faintly under the solar wind, unaware of the storm about to descend. Images from orbiters revealed the stillness of its vast plains, the shadowed canyons of Valles Marineris, and the frozen caps of its poles. For centuries, the planet had been silent, its geological clock ticking only through the occasional dust storm or meteorite strike. Now it stood at the threshold of something beyond comparison, a meeting of cosmic histories that transcended its quiet isolation. Every surface feature, every grain of regolith, every molecule of carbon dioxide in the air was about to be reshaped by the arrival of something from the deep unknown. The data flowing back from Webb grew richer as the object neared. Its infrared detectors revealed that the leading edge of 3I Atlas had begun to glow faintly from solar heating. But what drew particular fascination was the irregularity of that glow. Certain spots reflected heat far more efficiently, suggesting inclusions of metallic minerals or crystalline structures unknown in the solar system. Those anomalies hinted at origins in environments far more extreme than any within our local stellar neighborhood. Perhaps the remnants of a supernova shockwave that had once shredded an ancient planetary system and flung its debris into the interstellar gulf. If that were true, then 3I Atlas was not merely a rock from another system, it was the condensed history of stellar death and rebirth, now on course to become part of another world story. Every second of data deepened the awe surrounding the event. The object's trajectory cut across Mars's orbital plane with exquisite precision, as if guided by an invisible hand of cosmic geometry. Even the smallest perturbations were accounted for: solar radiation pressure, the influence of Jupiter's gravity, and minute thrusts from outgassing jets. The final calculations showed the moment of atmospheric entry would occur at an angle that maximized both frictional heating and surface penetration. It would not merely graze the atmosphere or disintegrate harmlessly. It would plunge deeply enough to deliver its full kinetic energy into the Martian crust. The simulations predicted that the resulting shockwave would be visible even from Earth's orbit, a bright transient flash of light that would outshine anything Mars had displayed before. In universities and research institutes, physicists and geologists prepared their models for what was to come. The moment of collision would trigger a cascade of interactions: compression waves racing through the ground, vaporization of rock and metal, and a colossal plume of molten debris surging into the thin air. That plume, expanding outward at supersonic speeds, would carry signatures of both Martian and interstellar matter, a literal fusion of worlds. As it cooled and condensed, fragments would rain down across hundreds of kilometers, blanketing the surface in a new geological layer, a stratum that future explorers would one day drill into and study. Long after the impact itself faded from memory, the planet's rocks would hold the story in microscopic detail, telling of the day when something from another star came to rest on the red plains. While most of humanity watched from afar, there were machines on Mars that stood in silent readiness. The Perseverance rover, built to search for traces of ancient life, had become an unintentional witness to a cosmic spectacle. Its panoramic cameras were reprogrammed to capture rapid image sequences, its spectrometers recalibrated to detect transient heat and radiation. Even the aging Curiosity rover, though limited in mobility, was set to record environmental changes: the tremors that might ripple through the ground, the shifts in atmospheric pressure, the rise of dust. In orbit, the Mars Reconnaissance Orbiter was positioned for a once-in-a-lifetime observation: the formation of a fresh crater by an object not from within the solar system, but from the void between stars. The implications extended beyond geology or astronomy. The prospect of interstellar material striking Mars reignited debate about the transfer of biological precursors through space. Could complex molecules endure the fiery descent through an atmosphere, survive the impact, and later integrate with planetary chemistry? Some researchers argued that the violent energy of collision might actually catalyze new compounds, fusing carbon and nitrogen in ways that ordinary chemistry could not achieve. Others speculated that frozen organic ices within 3I Atlas might vaporize into Mars's thin air, forming transient clouds rich in exotic molecules. These scenarios suggested that the boundary between planetary systems was far more porous than once imagined, that the universe itself might be engaged in a continuous dialogue of material and molecular exchange. As the interstellar traveler closed the final gap, its path crossed the orbits of Mars's two tiny moons, Phobos and Deimos. Calculations indicated it would pass well clear of both, but the gravitational perturbations were measurable. The moons trembled minutely in their orbits, a subtle echo of the massive forces unfolding around them. In the days following, those measurements would help refine models of gravitational interaction and orbital resonance, offering new insights into how even small celestial bodies respond to passing interlopers. The event was not just an isolated impact, it was a web of interconnected phenomena radiating outward through the solar system, each revealing another layer of cosmic complexity. For planetary defense specialists, 3I Atlas represented both a validation and a warning. It confirmed that objects from beyond the solar system could intersect planetary orbits with devastating precision. The statistical improbability of such an event did little to comfort those who now considered the possibility of a similar encounter with Earth. The rarity of interstellar visitors had long been a reassurance, but this new trajectory shattered that complacency. If one such object could be captured or redirected toward Mars, others might follow, each carrying the unpredictable legacy of alien systems. The universe, it seemed, was not content to let its wanderers drift harmlessly through space. Sometimes it sent them home with a target. Meanwhile, the Webb telescope continued to transmit a flood of data. Its detectors captured faint spectral lines as sunlight refracted through the gases venting from the object's surface. The composition of those gases stunned researchers, traces of cyanides, silicates, and complex organosulfur molecules, none of which had been detected in such abundance before. These compounds suggested that 3I Atlas had formed in a cold, carbon-rich region of its original system, possibly within the remnants of a protoplanetary disk surrounding a dying star. In a sense, it carried within it the fossilized memory of another world's formation, and now, as it approached Mars, it was about to inscribe that memory onto the surface of a new one. The night before the predicted impact, every observatory capable of observing Mars was engaged in continuous tracking. The planet, bathed in the faint reddish hue of reflected sunlight, seemed unchanged. Yet beneath that serenity lay a growing tension, as if the cosmos itself were holding its breath. The object approached from the planet's night side, invisible to optical telescopes, but glowing brightly in infrared. The temperature readings spiked as it entered the outer edges of the Martian atmosphere, and for a fleeting moment, its tail blazed into visibility, a streak of silver-white light across the blackness, captured in a single breathtaking image by Webb sensors. That image would become one of the most iconic in the history of astronomy, the first recorded descent of an interstellar object into a planetary atmosphere. At that same moment, instruments aboard the orbiters began to register changes. The thin upper layers of Mars's air ionized under the object's passage, producing a faint aurora-like glow. Radio signals fluctuated as charged particles scattered across the planet's magnetic field. Within seconds, the main body of 3I Atlas plunged deeper, and the sensors saturated with energy readings beyond their normal scale. Even before the visual confirmation arrived, the data spoke unmistakably. The impact was underway. The world did not see it directly with the naked eye, but through the lenses of its machines, it watched. A brilliant flash erupted from the Martian surface, spreading like a sunrise that lasted only moments. The shockwave propagated outward, carrying incandescent dust high above the atmosphere. The plume expanded rapidly, forming a vast mushroom-like cloud of molten material and vaporized rock. For several minutes, Mars shone brighter than any star in its vicinity. The data streamed across millions of kilometers to Earth, a silent cascade of photons bearing witness to the birth of a new crater, a new story carved into the face of the red planet. In the aftermath of that blinding moment, the telescopes continued to record. The thermal bloom persisted, slowly fading as the molten ejecta cooled. From orbit, faint glimmers of reflected sunlight revealed the growing outline of the impact basin, a fresh wound on the planet's surface, vast and symmetrical. The Webb telescope's sensors detected the residual glow of ionized gases dispersing into space, forming a thin, ephemeral veil around Mars. It was as if the planet had exhaled, releasing its ancient dust into the void as testimony to what had just transpired. The data analysis began immediately. Spectral readings from the expanding cloud revealed an astonishing mix of elements: iron, magnesium, silicon, nickel, and traces of exotic isotopes not naturally found on Mars. These isotopes were the unmistakable fingerprints of interstellar origin, confirming beyond doubt that 3I Atlas was indeed a traveler from another star. For scientists, This was a discovery of profound significance. It proved that matter from beyond the solar system could integrate with local planetary environments, potentially influencing their chemistry and evolution. The cosmic exchange that had been theorized for decades had now been witnessed directly, its evidence glowing in the skies above Mars. As the hours passed, the dust plume began to settle, blanketing the nearby terrain. The orbiter's cameras captured mesmerizing images, a pale red haze drifting across the horizon, scattering the weak sunlight into muted tones. The planet's once familiar landscape had been subtly transformed. New shadows stretched across the plains, new textures appeared where smooth dust had once lain undisturbed. For planetary geologists, it was like seeing Mars reborn, its surface rewritten by the forces of deep space. The crater, when fully mapped, measured over 100 kilometers in diameter, its rim glinting with freshly exposed rock. Around it, streaks of dark ejecta extended for hundreds more, marking the reach of the explosion's fury. The energy of the collision had generated seismic waves that rippled through Mars's interior. Instruments left by the InSight lander, though dormant for months, briefly reactivated from the vibrations, transmitting ghostly echoes of the planet's trembling. Those readings provided an unexpected gift, a fresh map of Mars's subsurface structure, revealing layers of crust and mantle previously beyond detection. Even in destruction, the event had become an instrument of discovery, offering new windows into the planet's hidden depths. Among scientists, conversation turned rapidly from observation to interpretation. The collision scale was such that it might influence the Martian climate, however briefly. Dust suspended high in the atmosphere could scatter sunlight, cooling the surface and altering wind patterns. If 3I Atlas contained significant amounts of water ice, as early readings suggested, then steam released during impact could momentarily thicken the atmosphere, perhaps even generating transient clouds. The idea of rainfall, even for a few fleeting moments, captured imaginations. Though unlikely to last, the prospect of moisture returning to Mars's sky, carried by an interstellar messenger, was poetic beyond measure. In the laboratories of Earth, scientists processed data with unprecedented urgency. Spectral analysis teams dissected the incoming readings line by line, searching for chemical anomalies. Among the familiar Martian signatures, they found something extraordinary: traces of isotopic ratios inconsistent with any known solar system material. These ratios hinted at formation in environments rich in neutron capture elements, conditions typically found near dying stars or in ancient supernova remnants. It meant that 3I Atlas was likely a fragment of a planetary body that had once orbited a star older and more massive than the Sun, a survivor of stellar death, now merged with a planet still waiting to host life. Astrobiologists saw in this event the potential blueprint of cosmic seeding. The heat of impact could have synthesized new complex molecules in the Martian soil, perhaps even creating transient organic compounds that would linger in its dust. Instruments aboard orbiters detected faint ultraviolet fluorescence consistent with such reactions, though confirmation would take months of analysis. The idea that life's raw materials had just been delivered, again, as they may have been billions of years ago, to the red planet filled researchers with wonder. Mars, long considered barren, had been touched by the chemistry of another world. In the following days, Mars's orbiters began to transmit clearer images of the impact site. The crater's central peak shimmered with reflective materials, possibly glassy silicates formed by the intense heat of the explosion. Around its rim, darker bands suggested layers of ancient sediment now brought to the surface. Those layers could reveal records of Mars's distant past, clues to its lost oceans, its vanished magnetic field, and the climate shifts that had shaped its evolution. It was as though the interstellar object had not only scarred the planet but also peeled back its geological veil, exposing secrets buried for eons. The James Webb Telescope continued to monitor the site long after the initial burst faded. Its sensors detected faint thermal emissions as the planet's surface slowly cooled, and subtle variations in infrared reflectivity as dust settled into new formations. Over weeks, scientists noticed a remarkable pattern. The material ejected from the crater contained reflective particles unlike any previously cataloged on Mars. These particles exhibited spectral features suggesting crystalline carbon structures, perhaps remnants of 3I Atlas's inner core. If confirmed, It would mean that the object had carried diamond-like compounds forged under immense pressure in another planetary system. The thought that such alien crystals now glittered across the Martian surface was both humbling and exhilarating. On Earth, humanity's perception of the cosmos subtly shifted. The boundaries between stars, once considered insurmountable, now felt permeable. The realization that matter from distant systems could physically merge with planets in our neighborhood brought the universe closer in a tangible way. People who had never cared for astronomy before found themselves staring at images of Mars with newfound reverence, aware that an event of cosmic significance had unfolded within the reach of their instruments. The collision became a symbol of connection, a reminder that every atom, every particle of dust was part of a grander circulation of matter across the galaxy. For the engineers and scientists behind the James Webb Telescope, this moment validated decades of vision and labor. The telescope had not been built with this event in mind, yet it had proven to be the perfect witness. Its infrared eyes, sensitive beyond precedent, had captured every nuance of the unfolding drama, from the cold stillness of the approaching object to the incandescent fury of its impact. In those datasets lay the chronicle of an entire cosmic narrative, written in light. Future generations of researchers would study those records, reconstructing the event in exquisite detail, tracing every molecule and photon back to its source. The longer scientists studied the data pouring in from every instrument, the more intricate the picture of 3-year Atlas's arrival became. It was not a single, simple event, but a series of interconnected transformations that radiated outward through Mars's environment, each leaving traces in the atmosphere, the soil, and even the electromagnetic space around the planet. In the first weeks following the impact, Mars's thin sky remained veiled in a soft coppery haze. The sunlight that reached the surface was muted, filtered through clouds of suspended particles that shimmered faintly with metallic hues. Instruments aboard the ExoMars orbiter detected microscopic grains of material drifting at high altitude, each grain reflecting a strange spectral light, a kind of cosmic dust never before seen in our solar system. These particles bore the spectral fingerprints of compounds not native to Mars, some crystalline, others amorphous, each a survivor of a collision that had fused two worlds into one. The James Webb Telescope continued to track the gradual cooling of the impact site. For weeks, the crater radiated heat like a newborn star, a glowing wound visible even in the far infrared spectrum. The thermal gradient stretched far beyond the immediate impact zone, suggesting that underground channels of melted rock and vaporized minerals were still shifting and settling. Mars, long considered geologically dormant, seemed momentarily alive again, its crust groaning and breathing under the shock of interstellar energy. Seismic waves propagated through its mantle in concentric ripples, their echoes faint but measurable even by instruments billions of kilometers away. The planet, in a sense, was still speaking through vibrations, carrying the resonance of the cosmic strike through its bones. Scientists studying the data began to notice something extraordinary about the composition of the ejecta cloud. The high-velocity material that had escaped Mars's gravity contained clusters of molecules previously unseen in any natural sample. Complex chains of carbon, nitrogen, and silicon woven together in patterns that hinted at organic precursors. These were not living molecules, but they were structured with uncanny intricacy, as if they had once been exposed to environments where complex chemistry thrived. The idea that 3I Atlas had carried molecular relics from another star system now seemed almost undeniable. These compounds, forged under alien suns and temperatures, had survived a journey across interstellar space only to be reignited by a planetary impact. The irony struck everyone. The violence of collision had not destroyed the complexity within the object, but instead had revealed it. Researchers at spectroscopic laboratories around the world pored over the data with reverent focus. Each signature they extracted told a new story. Molecules built from isotopes unknown in the solar system, elements arranged in configurations that challenged conventional chemical models. These discoveries forced a re-evaluation of how matter evolves between stars. Perhaps interstellar space was not as barren as once imagined. Maybe, Drifting among the gas and dust, there existed pockets of molecular richness, remnants of planetary systems long gone that carried the seeds of future worlds. In that context, the collision of 3I Atlas with Mars was not a random accident, but part of a much larger cycle, the universe recycling its own complexity, scattering it among the stars like pollen on the cosmic wind. As the dust settled, high-resolution imaging from orbiters began to reveal the full scale of the crater. It sprawled across the Martian surface in a vast oval basin nearly 200 kilometers wide. Its rim rose sharply against the surrounding plains, glowing faintly under the pale sunlight. The floor of the crater was a chaos of fractured rock, molten glass, and newly formed minerals, their colors ranging from deep crimson to shimmering silver. In certain regions, streaks of bright blue material appeared, an anomaly that captivated geologists. Spectral analysis suggested that these streaks were deposits of hydrated silicates, formed when the intense heat of the impact melted subsurface ice. The collision had not only vaporized part of Mars's crust, but also released ancient water trapped for eons beneath its surface. For a brief moment in geological time, Mars had exhaled water again, its lifeless desert awakening under the touch of an interstellar visitor. That revelation sent shockwaves through the astrobiological community. Water, even transient, meant potential for chemistry, the kind of chemistry that, given time, could lead to life. The possibility that the impact might have created ephemeral microenvironments, warm and wet within the cracks of the crater floor, opened a new realm of speculation. Could the fusion of Martian and interstellar materials give rise to something unprecedented? While no one expected life to emerge overnight, the thought that Mars might now host unique chemical reactions, distinct from any that had ever occurred there before, was electrifying. If future missions could reach the crater and sample its soil, they might find compounds unlike anything else in the solar system, a true blending of planetary chemistries. In the following months, Mars's atmosphere underwent subtle changes. Trace gas sensors recorded a rise in methane concentrations, along with faint signatures of acetylene and formaldehyde, molecules that hinted at active chemical processes. The source was uncertain. Some argued that the gases were residual emissions from the impact, products of heated rock and vaporized minerals. Others speculated that they might originate from decomposition of the alien compounds within 3I Atlas itself, now interacting with the Martian environment. Whatever their origin, the presence of such gases reignited debates that had simmered for decades. Could Mars still harbor chemical or even microbial activity, perhaps reawakened by external stimuli? The timing seemed too coincidental to ignore. Something had changed, and the fingerprints of that change were drifting through the thin, ruddy air. The event also drew unexpected insights into planetary acoustics. Instruments aboard the surviving Mars orbiters detected low-frequency vibrations persisting long after the impact, resonating through the planet's crust like a planetary heartbeat. These vibrations carried information about the internal structure of Mars, revealing density variations and subsurface boundaries with unprecedented clarity. Geophysicists realized they could use the data from this cosmic hammer strike to refine models of Mars's core composition, perhaps even settling the debate about whether it was still partially molten. What had begun as an astronomical accident was turning into one of the most productive scientific experiments ever conducted, one orchestrated not by design, but by the impartial mechanics of the universe. Meanwhile, on Earth, the cultural impact of the event deepened. Artists, writers, and filmmakers were captivated by the imagery of two worlds colliding. It became a universal symbol of transformation, of how even the most distant and cold parts of the cosmos could suddenly touch and reshape one another. Humanity saw in the event a mirror of its own curiosity, a reminder that exploration was not merely about reaching outward, but about witnessing the interconnectedness of all existence. The collision transcended science. It entered myth, joining the ranks of stories that define eras of awakening. For engineers and scientists working on Mars missions, the event also brought a new sense of urgency. The impact site, now known informally as the interstellar basin, became the prime target for future exploration. Plans for robotic missions were redrawn to include paths leading to its rim. Sample return designs were adapted to handle potential contamination by interstellar material. If fragments of 3I Atlas could be collected and brought back to Earth, They would provide the first tangible evidence of material from beyond our solar system, evidence that might rewrite the story of cosmic formation. It would be a chance to touch another system's debris with human hands, to hold the remnants of an alien sun's history. Within the scientific community, discussions turn to the broader implications for planetary defense and cosmic probability. Statistically, the likelihood of an interstellar object striking a planet within the inner solar system was vanishingly small. Yet it had happened, and with such precision that coincidence seemed almost philosophical. Some researchers began to explore the gravitational pathways that could have led 3I Atlas into Mars's orbit, tracing its long journey backward through the solar system. Their models suggested a complex dance of celestial mechanics, a sequence of encounters with Jupiter's massive gravity, subtle perturbations from solar radiation, and self-generated thrust from outgassing. Each tiny adjustment had accumulated over millions of kilometers, guiding the object toward Mars like a thread drawn through a loom. The universe, indifferent yet ordered, had orchestrated the event with mathematical inevitability. The data also revived curiosity about earlier interstellar visitors like Oumuamua and 2I/Borisov. Comparisons showed that while those objects had passed through harmlessly, their compositions might have shared characteristics with 3I Atlas, volatile rich, carbon-heavy, and capable of interacting with solar radiation in unpredictable ways. The realization that 3I Atlas had not merely passed through but collided suggested that interstellar objects might play a greater role in shaping planetary systems than previously believed. Over billions of years, countless such encounters could have altered the chemistry and evolution of worlds, seeding them with materials from far-flung stars. Each impact, rare on human timescales, would contribute to the grand galactic exchange of matter. Mars's encounter might simply be the latest verse in that ancient cosmic symphony. As the Webb telescope continued its surveillance, new phenomena emerged. The infrared afterglow of the crater began to pulse faintly in rhythmic intervals. Initially dismissed as sensor noise, the pattern persisted across multiple observations. Spectral analysis revealed that the pulses corresponded to thermal fluctuations caused by convection currents beneath the surface, heat trapped in molten channels rising and falling as it cooled. The discovery suggested that the impact had generated a transient magma reservoir, a temporary pocket of molten rock deep beneath the crater floor. For the first time in millions of years, Mars had a partially molten region near its surface, a fleeting echo of the planet's once fiery youth. Geologists marveled at the notion that an interstellar impact had briefly reawakened Mars's internal fire. The magnetic readings from orbit confirmed it. Localized magnetic anomalies began to appear around the crater, faint but measurable. These fields were likely generated by electrically conductive fluids moving through the subsurface, molten minerals and ionized gases stirred by the impact's heat. Mars, which had long since lost its global magnetic field, now bore a temporary magnetic heartbeat in the region of the collision. Though destined to fade with time, it was a profound reminder of how dynamic planetary systems remain, even in apparent dormancy. The event had not only altered the surface, it had momentarily restored one of the fundamental properties Mars had lost billions of years ago. For climatologists studying the planet's fragile atmosphere, the weeks following the impact revealed unexpected complexities. The dust cloud that enveloped Mars behaved differently from typical dust storms. It contained particles of varying densities and compositions, some metallic, others carbon-based, leading to unique scattering patterns. The result was a series of stunning optical phenomena. Faint halos around the sun, twilight glows that lingered longer than expected, and a diffused luminescence that gave the planet an almost ethereal appearance. Observers described Mars as glowing from within, its light no longer merely reflected but refracted through a veil of interstellar minerals. These visual transformations were temporary, yet they etched themselves into the collective imagination. A planet transformed into a cosmic lantern, shining with the memory of a star it had never known. On Earth, debates erupted about the philosophical meaning of what had occurred. Was this event a reminder of cosmic fragility or a symbol of cosmic continuity? Some saw it as a warning, a demonstration of how powerless even planets are before the forces that govern the universe. Others saw it as a revelation, proof that the universe is deeply interconnected, that creation and destruction are inseparable parts of the same process. Religious thinkers spoke of divine choreography, philosophers of cosmic cycles, and scientists of material exchange. Every field found its own metaphor in the event. Mars had become a mirror, reflecting not just sunlight but humanity's own questions about purpose and place in the vastness. The continuing analysis of debris orbiting Mars yielded further surprises. Small fragments of 3I Atlas that had escaped the initial impact were now in stable orbits around the planet, forming a tenuous ring system. These particles, too small to see with the naked eye, glittered faintly in the reflected light of the sun, a ghostly halo around the red world. It was a phenomenon that would not last long, perhaps a few years before the particles re-entered the atmosphere or dispersed into space. But while it existed, it turned Mars into a planet with rings, however delicate. Astronomers around the world trained their instruments on the shimmering band, eager to capture images before it faded. The sight of Mars encircled by a faint dust-borne ring became one of the defining visual symbols of the era, a testament to how one cosmic encounter could change the face of a planet. The formation of the ring system also carried scientific implications. The particles' orbital distribution provided clues about the velocity and angle of impact, while their composition offered additional evidence of 3I, Atlas's origin. Some fragments appeared rich in metallic hydrogen compounds, materials that could only exist under extreme pressures, perhaps deep within the core of the original interstellar body. Their brief survival in space offered a fleeting glimpse into the internal structure of worlds that formed around alien stars. For researchers in material science and physics, the discovery opened a new frontier, the study of exotic matter not from theory, but from tangible observation. Months turned into years, and the after effects continued to ripple through both Mars and human understanding. The crater stabilized, its molten interior cooling into hardened glass and stone. The once glowing rim dulled to a dark scar, yet from orbit, it remained one of the most visually striking features on the planet. Dust storms carried traces of its material across continents, subtly altering the color of distant dunes. Every gust of Martian wind became a carrier of history, spreading fragments of interstellar origin across the planet's face. In a literal sense, Mars was now part alien, its dust enriched with compounds from another star, its landscape forever marked by the visitor that had arrived, uninvited yet transformative. On Earth, the impact had sparked a new wave of scientific ambition. Space agencies accelerated plans for interplanetary missions, seeing in the event not tragedy, but opportunity. The idea of an interstellar sample return mission moved from speculative to urgent. Engineers began designing specialized probes capable of collecting and preserving material without contamination, knowing that whatever lay within that crater might redefine planetary science. Private space companies, too, joined the race, envisioning missions not just to study but to harvest interstellar materials for analysis and potential technological application. The boundary between exploration and utilization began to blur. Humanity was entering a new phase of direct engagement with the broader galaxy. Among the most haunting discoveries came from the continued monitoring of the crater's electromagnetic emissions. Deep within the basin, sensors detected periodic bursts of radio frequency energy, weak but consistent. Initially dismissed as geological noise, the signals exhibited a strange regularity, like pulses corresponding to cooling cycles deep underground. These pulses carried harmonic structures that intrigued physicists. They might simply have been the result of magnetic minerals realigning as temperatures dropped, or they could represent oscillations caused by crystalline formations within the fused rock. Either way, Mars had begun to hum faintly in the radio spectrum, singing an aftersong of its encounter with the interstellar intruder. The study of these signals became a field unto itself. Some scientists speculated that the frequency patterns could be used to deduce the rate of mineral formation and crystallization in post-impact conditions. Others, less restrained, whispered about the possibility of encoded natural order, patterns arising not from randomness, but from the inherent logic of physical law repeating across cosmic scales. The idea that the universe might express itself through resonance, that every collision or fusion of matter produces a unique frequency signature, gave birth to an entirely new philosophical movement. The notion that the cosmos was a symphony of matter and motion, each note played in impacts and orbits, stars and dust alike. For Mars, the symphony continued. Over time, the planet's weather patterns adjusted to the new dust equilibrium. Winds carried the finest interstellar grains high into the atmosphere, where they remained suspended, altering the planet's albedo and temperature balance. The global average temperature dropped by a fraction of a degree, a small change, yet enough to affect circulation. Polar vortices intensified, redistributing carbon dioxide frost and subtly reshaping the seasonal cycles. The collision had not only changed Mars's geography, but had nudged its climate onto a slightly different path. Even if transient, that change was measurable, a sign that the influence of 3I Atlas extended far beyond the immediate site of impact. Through all of this, the James Webb Telescope remained the quiet chronicler of every stage. Its instruments had witnessed the interstellar traveler's approach, the moment of collision, the rise of the dust, and the slow fading of the afterglow. But it had also witnessed something else, something more abstract yet deeply human. In every burst of data transmitted back to Earth, there was the reflection of curiosity, of a species capable of understanding what it was seeing. The telescope had not only extended human sight, but had deepened human awareness. It had shown that the cosmos is not static, that creation and destruction are woven together into an endless continuity of motion and matter. The silence surrounding Mars in the years following the 3I Atlas collision had an almost sacred quality to it. The planet, long known for its barren serenity, now held a memory etched not only in its rock, but in its very atmosphere. Every grain of dust that drifted across the crimson plains was a particle of history, some fraction of Mars itself, some remnant of an interstellar body that had journeyed through the cold corridors between stars. The crater, the luminous basin born of that encounter, had cooled into stillness, yet it remained far from dead. Beneath its quiet surface, slow reactions continued, whispering to the instruments orbiting above that the energy of impact still lingered, diffusing its echoes into the planet's crust. Years of continuous monitoring revealed that Mars was no longer entirely what it had been. The mineral composition of the dust storms had changed subtly. Small traces of iridium, nickel, and rare isotopes now appeared in higher concentrations than ever before. Some of these elements did not match known Martian ratios and bore the unmistakable signature of interstellar origin. Each storm carried that alien material across thousands of kilometers, seeding valleys, mountains, and plains alike. It was as if the red planet had been painted anew, its surface enriched, its chemistry rewritten in subtle gradients that told of its meeting with something ancient and foreign. As the orbiters continued to scan the impact basin, new features began to emerge. Thermal imaging revealed faint lines of warmth beneath the crater floor, narrow channels of heat that persisted far longer than models predicted. These weren't remnants of active volcanism. They were something different, possibly the lingering result of minerals rearranging at the molecular level, releasing stored energy as they stabilized. This slow cooling produced minute electromagnetic pulses, and these pulses were being recorded not only by orbiters, but also faintly by deep space instruments on Earth's side of the solar system. Mars, it seemed, was still talking, transmitting a faint hum that oscillated through the void like a distant heartbeat. Scientists debated whether it was purely a geological phenomenon or something more complex, a resonance emerging from the mingling of materials never before in contact. The faint radio emissions carried with them a rhythm that fascinated mathematicians and physicists alike. The intervals between pulses followed no simple pattern, yet they contained a strange internal logic, a kind of self-similar sequence that seemed to evolve with time. Some saw it as coincidence, the chaotic rhythm of a cooling planet. Others, more speculative, wondered if the pattern might encode something deeper, a natural language of physical resonance arising spontaneously when interstellar and planetary materials interacted. These were not the whispers of intelligence, but rather the mathematics of nature finding harmony in collision. In that sense, Mars had become an instrument of the cosmos itself, vibrating to a song composed by the meeting of two worlds. Meanwhile, the scientific mission known as Aeneas finally reached orbit. It had been designed in the aftermath of the collision, its purpose clear and bold: to study the interstellar basin in situ. The spacecraft carried drilling drones capable of descending into the crater and collecting samples from deep beneath the fused surface. For years, humanity had stared at the site from afar, interpreting data through light and spectrum. Now, for the first time, it was preparing to touch the relics of an alien system directly. As the lander descended through Mars's thin atmosphere, dust from the impact still hung faintly in the air, refracting sunlight into soft halos. The planet welcomed its mechanical visitor in silence, its scar glimmering faintly beneath the dawn. When the first drilling drone reached the ground, it encountered unexpected resistance. The crust at the crater's center was harder than any known basalt, its density so high that the instruments initially assumed a malfunction. Only after recalibration did the sensors reveal the truth. The rock was infused with metallic compounds that had crystallized under unimaginable pressure. These formations had the appearance of obsidian but shimmered with an iridescent sheen. Under microscopic analysis, their lattices appeared fractal. Each crystal contained within it smaller self-replicating structures, echoing patterns down to the atomic level. The material defied easy classification. It behaved as both a conductor and an insulator, depending on the energy applied, and its resilience suggested that it could withstand temperatures that would vaporize ordinary metal. The collision had produced a material unknown to science, a byproduct of interstellar chemistry meeting Martian geology. Further beneath the surface, the drones uncovered veins of a different substance, translucent filaments that glowed faintly when exposed to light. These strands wound through the rock like veins of frozen lightning. Chemical analysis showed that they contained trapped gases, including hydrogen cyanide, ammonia, and carbon dioxide, the building blocks of complex organic chemistry. It appeared that during the moment of impact, as pressures soared and temperatures reached thousands of degrees, these gases had fused into the lattice of the rock instead of escaping. Within those threads lay a fossilized chemical memory of the impact's energy, a frozen record of the transformation that had bridged worlds. Scientists on Earth compared it to amber, nature's way of preserving moments in time, but on a planetary scale. The samples sent shockwaves through the scientific community. In laboratories on Earth and in orbit, researchers began to experiment with the materials under controlled conditions. When exposed to low-frequency radiation, the crystal fragments emitted faint electrical discharges as if responding to stimulation. When heated, they exhibited unusual superconductive behavior. The most astonishing discovery came when one sample, subjected to gradual increases in pressure, began to alter its molecular structure autonomously, reconfiguring itself to maintain stability. It was as if the material were capable of self-organization, adapting to environmental changes without external guidance. This was not life, but it mirrored the principles that underlie living systems, the capacity for dynamic equilibrium, for self-preservation through transformation. The interstellar material had brought with it the raw physics of adaptability. Philosophers and scientists alike found themselves confronting questions that stretched the boundaries of known science. Was self-organizing matter a precursor to life, or was it simply a property of energy-rich materials under specific conditions? Could similar events elsewhere in the galaxy have given rise to actual living organisms? The collision on Mars had become a natural laboratory for exploring such questions, a canvas on which the laws of chemistry and complexity played themselves out in visible form. Some began to speculate that the seeds of life might not emerge merely from organic molecules, but from the capacity of matter itself to adapt, to reorganize in ways that favor persistence and stability. Perhaps the universe's first steps toward consciousness were written in such materials, long before cells or genes existed. While laboratories across the world wrestled with these implications, the crater continued to evolve under the Martian sky. Over time, winds carved channels into the fused glass, revealing layers of color that glimmered under sunlight. Violets, golds, and greens, all reflections of the exotic minerals within. High-resolution imagery revealed a pattern to the erosion. The winds seemed to follow paths defined by the crater's magnetic contours. It was as though invisible lines of force shaped the landscape, guiding the motion of dust and sand. Mars had become a planet of strange geometries, its physics slightly altered in the wake of interstellar contact. The interplay between its atmosphere, magnetic fields, and surface minerals created weather patterns that defied old models. Small whirlwinds formed spontaneously above the crater, their cores illuminated by static discharges. These luminous vortices, twisting silently under the thin air, became known as ghost storms. They were the planet's quiet reminder that even in desolation, movement never ceases. Meanwhile, the faint ring of debris orbiting Mars had begun to thin, but before it faded completely, it offered astronomers a final treasure. Embedded within those dust particles were microcrystals whose composition was unlike any material found either on Mars or Earth. When these grains were analyzed through spectrometry, they revealed a strange symmetry. Atoms arranged in patterns that did not conform to known crystallographic systems. The arrangement was not random. It appeared mathematically perfect, like a frozen wave of probability. Quantum physicists studying the data noted that such configurations could only occur under conditions where matter was briefly subjected to quantum coherence on a macroscopic scale. Somehow, in the instant of impact, regions of matter had achieved a fleeting unity, a moment where the distinction between particle and wave dissolved. That instant had now been immortalized in the structure of dust. The implications reached deep into theoretical physics. It suggested that under extreme cosmic conditions, matter could temporarily behave as if it were aware of itself, as if every particle were part of a single, coherent entity. This realization sent shockwaves through the scientific world, not because it implied consciousness, but because it hinted that the universe naturally tends toward coherence, even in chaos. The collision between three Atlas and Mars had not only been a physical event, it had been an experiment in the very architecture of reality. It offered proof that order could emerge from violence, symmetry from explosion. For many, it became a symbol of the universe's innate intelligence, an intelligence expressed not through thought, but through the elegance of its laws. The mission continued, and as the drones dug deeper, they uncovered the remnants of a cavity beneath the crater. A hollow chamber formed by trapped gases during the impact. When sensors were lowered into the cavity, they detected something entirely unexpected: a thin film of moisture coating the inner walls. This water was not part of any known aquifer. It had condensed from chemical reactions between interstellar volatiles and Martian minerals, forming liquid in an environment where liquid water should not persist. The discovery of this pocket stunned the world. Within that dark cavity, the temperature and pressure conditions were marginally stable enough to support temporary liquid, a small hidden oasis born from collision. For the first time in billions of years, water had pooled naturally beneath the Martian surface. What captivated researchers even more were the spectroscopic readings from that liquid. The water contained dissolved organic molecules of incredible complexity, long carbon chains with branching structures, molecules that could, under the right conditions, form the precursors of cellular membranes. They were not biological, but they were unmistakably prebiotic. It was as if the universe itself had reenacted the earliest stages of life's chemistry, choosing Mars as its stage. The crater had become a crucible, a microcosm of creation, where energy and matter had fused into something that carried potential. For planetary scientists, this was a revelation that transcended even the discovery of alien minerals. It was the demonstration that life's essential chemistry could emerge spontaneously from the meeting of worlds. While analysis continued, humanity began to look at Mars differently. The red planet had always been a symbol of exploration, of reaching beyond the familiar, but now it represented something deeper. It was no longer just a destination, it was a participant in the grand conversation of the cosmos. Its collision with 3I Atlas had woven it into the interstellar fabric, linking it chemically and symbolically to systems light years away. The materials within its crater were not Martian, not solar, but galactic. The event had reminded humanity that planets are not isolated, that the universe's history is shared across unimaginable distances. Every rock, every molecule, every atom carried the memory of stars that once burned elsewhere. Over time, the study of interstellar impacts became a new discipline, merging astrophysics, geology, and biology into a single continuum. Researchers began to see planets not as static spheres, but as living participants in the cosmos's creative process. Impacts, once feared for their destruction, were reinterpreted as moments of renewal. Cosmic exchanges where energy and matter fused to give rise to new possibilities. Mars's collision became the template for understanding how the universe evolves through interaction rather than isolation. The phrase cosmic inheritance entered the lexicon, describing how every world inherits the chemistry of others through the occasional touch of catastrophe. Meanwhile, deeper exploration of the crater revealed a slow but steady transformation occurring within the rock. The crystalline structures, once inert, were subtly altering. Their coloration shifted over time, suggesting internal reconfiguration at the atomic level. Some scientists theorize that cosmic radiation, interacting with the unique mineral lattice, was catalyzing a kind of self-annealing process, matter evolving in response to its environment. The idea that inorganic materials might display behaviors analogous to growth and adaptation unsettled traditional boundaries between living and non-living systems. The lines between biology and physics blurred in ways no one had anticipated. If matter could evolve, even in form and structure, what separated it from life except degree and complexity? As data from the Aeneas mission streamed back, humanity began to realize that 3I Atlas had delivered more than alien material. It had delivered a mirror. Through its impact, the cosmos was showing humanity the mechanisms of its own creation, the continual cycle of destruction and renewal that shaped not only planets but consciousness itself. Philosophers drew parallels between the event and human history, noting how civilizations, too, evolved through collision, through contact, conflict, and synthesis. Just as Mars had absorbed and transformed the interstellar visitor, so too did humanity grow through the meeting of worlds, ideas, and cultures. The story of 3I Atlas became not just a scientific chapter, but a parable of unity born from impact. Back on Mars, the interstellar basin began to display another subtle phenomenon. As seasons passed, light interacting with the crater's glassy walls produced strange optical effects. During twilight, the basin glowed faintly blue, a halo visible even from orbit. The glow was not merely reflection. It was photoluminescence caused by the excitation of certain minerals under ultraviolet radiation. But this light behaved in an unpredictable way. It intensified and faded in cycles that corresponded loosely to solar activity. Some speculated that charged particles from the sun were triggering the luminescence, while others suggested that the crater's materials had developed a resonance with electromagnetic fluctuations. Whatever the cause, the basin had become a kind of cosmic lantern, pulsing softly under the Martian sky, a reminder of the energy that had birthed it. The glow attracted metaphoric interpretation as much as scientific curiosity. It was seen as Mars's way of remembering. The planet's scar made luminous, its wound transformed into light. Every culture that looked upon those images found meaning in them. Some saw rebirth, others connection, others simply beauty born from violence. The interstellar basin became a symbol woven into art, literature, and philosophy. A bridge between the empirical and the eternal, between the measurable and the ineffable. The ongoing studies of the impact also reshaped understanding of interstellar dynamics. Astronomers began to reconsider the trajectories of other potential visitors, suspecting that the galaxy might contain countless bodies wandering between systems. These weren't mere fragments of rock, but carriers of history, each one potentially bearing the chemistry of worlds that no longer existed. 3I Atlas had proven that such wanderers could influence planetary evolution in profound ways. It became conceivable that Earth itself might one day receive such a visitor, and that our own planet's story might include the same interstellar inheritance now visible on Mars. The line between foreign and familiar began to dissolve, replaced by the recognition that the entire galaxy was one vast ecosystem of matter and motion. The years that followed the descent of 3I Atlas into Mars unfolded like the slow, deliberate turning of a cosmic page. What began as a single collision had become a chapter in the planetary biography of an entire world. The glow of the interstellar basin persisted as a quiet pulse on the Martian night side, faint yet constant, its blue light shimmering across the ancient sands. Over time, that luminescence began to reveal subtle fluctuations, patterns of intensity that followed not only the rhythm of solar radiation, but something deeper, as though the planet's new chemistry had found its own internal cadence. Every flare and dimming of light whispered the language of transformation, the aftermath of creation. Decades of observation brought new insights. The basin was not static. its mineral composition continued to evolve. When the Aeneas mission's successor, Sagan Horizon, arrived in orbit, its instruments detected faint traces of gases rising from fissures around the crater's rim: carbon monoxide, hydrogen, sulfur dioxide, and traces of xenon isotopes that could only have originated from deep beneath the surface. This outgassing was unexpected, not because of its composition, but because it implied subsurface activity in a region that had long been considered geologically dead. The collision had awakened something within the crust, ancient pockets of volatile material now interacting with the heat still emanating from the fusion of Martian and interstellar minerals. These gases rose through fractures, mingling with dust, and in the thin sunlight, their refracted colors formed faint, shimmering auroras near the equator. The planet that had once been only red now showed flashes of green, gold, and violet along its horizon. The scientific community began to speak of reactivation events, periodic episodes where residual energy from the impact reawakened dormant geophysical processes. These events followed no fixed schedule but were tracked through infrared imaging and electromagnetic data. Each pulse of energy triggered subtle shifts in the planet's magnetism, generating transient magnetic fields that rippled across the surface before dissipating. It was as if Mars, infused with interstellar compounds, had become a vast experiment in self-regulation, an inorganic organism finding balance between decay and renewal. Even the air above the basin seemed different, slightly denser, infused with microscopic particulates that altered how sunlight scattered. From orbit, the atmosphere shimmered faintly around that region, creating a halo effect that fascinated observers on Earth. The study of these transformations became the defining project of an era. Humanity's understanding of planetary science expanded beyond geology and climate into something more holistic, a recognition that worlds themselves were dynamic entities, capable of evolving in response to cosmic stimuli. The idea that planets could adapt, not in a biological sense, but in a systemic one, began to reshape philosophy and physics alike. Mars, through its encounter with 3I Atlas, had demonstrated that planetary evolution was not confined to its formation period. The boundaries between creation and destruction, between the living and non-living, had blurred. The event had turned the red planet into a crucible of cosmic evolution. The Sagan Horizon orbiter carried more advanced sensors than any before it, capable of detecting molecular shifts at atomic precision. It discovered that the minerals formed from the impact had continued to rearrange themselves, not randomly, but along patterns that mirrored thermodynamic optimization. In laboratory simulations on Earth, scientists observed similar behavior only in systems driven by feedback mechanisms. The Martian materials seemed to self-regulate energy distribution across their crystalline structures, dispersing heat evenly and minimizing internal stress. This property, unseen in any terrestrial mineral, suggested that the interstellar compounds introduced by 3I Atlas carried a fundamental principle of energetic balance. It was a kind of harmony built into their very existence. As the orbiter continued to map these properties, the patterns of change began to display emergent symmetry. When visualized through spectroscopic imaging, the basin's mineral evolution traced out spiraling forms reminiscent of galactic arms or biological growth. The resemblance was not literal, but the repetition of mathematical ratios across scales, from molecular arrangements to the distribution of minerals across the crater, was undeniable. The same proportions that governed galaxies, hurricanes, and DNA helices appeared within the structure of the crater itself. Some called it coincidence, others saw it as the fingerprint of universal order, a fractal blueprint running through every level of creation revealed now in the heart of Mars. Humanity's relationship with Mars changed irrevocably. The planet ceased to be merely a destination for exploration. It became a collaborator in the unfolding story of cosmic evolution. Philosophers began to speak of symbiotic cosmology, the idea that every world is an active participant in the universe's self-expression, that no event is isolated, and that matter communicates across scales in patterns of resonance. The collision of 3I Atlas had become a metaphor for unity, not a random act of destruction, but an exchange of essence, a dialogue between systems separated by light years but united by law and rhythm. On the planet's surface, the autonomous probes deployed by Sagan Horizon made discoveries that deepened this understanding. When they descended into the basin's fissures, They found streaks of dark, glass-like material embedded within lighter mineral layers. These streaks were found to be superconductive even at Martian temperatures, a property that defied current materials science. The energy field measurements taken near these formations showed faint electromagnetic oscillations, suggesting that the material interacted with the planet's ambient radiation in a cyclical fashion. It appeared to store and release energy with remarkable efficiency, not unlike a natural capacitor. If such materials could be harnessed, they might transform not only scientific understanding but technology itself. Mars, through its violent encounter, had become a planetary laboratory of innovation. Further analysis of these superconductive veins revealed another mystery. Their alignment corresponded almost perfectly with the planet's pre-existing fault lines, as though the energy of impact had mapped itself onto the planet's structural weaknesses, reinforcing them rather than destroying them. The planet had absorbed the collision by integrating the energy into its architecture. This adaptive response mirrored the way living systems absorb trauma, through reorganization, through strengthening of boundaries where they once were fragile. The resemblance between organic and inorganic adaptation grew harder to ignore. Matter, it seemed, possessed its own form of resilience, not as intention but as inevitability. In time, the crater began to show more visible changes. New mineral blooms appeared across its surface, patches of crystalline frost that formed in geometric shapes spreading outward each dawn and vanishing by midday. These frost formations were unlike any natural ice patterns known to science. Their geometry followed the same fractal symmetries observed in the mineral lattice below. They were the visible breath of the planet's internal transformation, ephemeral yet precise, the outer manifestation of processes unfolding deep within. From orbit, these frost blooms looked like delicate filigree, ephemeral hieroglyphs written each morning on the skin of Mars. Some speculated that they represented a form of chemical communication, a planet inscribing its own equilibrium upon its surface. As these phenomena continued, Mars's global climate began to show measurable shifts. The average atmospheric pressure in the equatorial regions increased slightly, likely due to the release of trapped gases. The planet's albedo changed, reflecting less sunlight and absorbing more heat. These small adjustments accumulated, leading to the slow warming of certain regions near the basin. In a few low-lying valleys, seasonal frost began to melt earlier than before, producing transient flows of brine-rich liquid that shimmered briefly before evaporating. Though fleeting, these trickles of water carried chemical signatures influenced by the impact materials, metallic ions and silicates from the crater's ejecta. It was as though the planet's hydrological memory had reawakened, guided by the interstellar seed that had struck it years before. The implications were staggering. If Mars could, through the infusion of alien compounds, reinitiate chemical and geological cycles once thought extinct, what did that say about the adaptability of worlds across the cosmos? Could similar events elsewhere reignite dormant planets, transforming them from barren relics into laboratories of complexity? Theories proliferated, proposing that interstellar collisions might act as catalysts for planetary renewal, a form of cosmic terraforming driven not by intention but by the universe's intrinsic dynamism. In this view, 3I Atlas was not an anomaly but a mechanism, a messenger of change that carried the chemistry of rebirth across star systems. Amidst this scientific renaissance, humanity's emotional connection to Mars deepened. The planet became a mirror for Earth's own fragility and potential. Artists painted the glowing basin as a cosmic wound that healed itself. Poets spoke of the fusion of dust and starlight, and philosophers described it as the universe's reminder that creation arises from impact, not avoidance. The event had reshaped more than geology. It had reshaped perception. Humanity no longer looked outward merely to explore. It looked outward to understand its own participation in the grand continuum of being. Back on Mars, the drones continued to probe deeper into the basin's heart. Eventually, they reached the layer where the last remnant of 3I Atlas was embedded. The fragment was smaller than expected, no more than a few meters across, but its properties defied comprehension. Its surface emitted no detectable light, yet its presence distorted nearby radiation fields. When measured, its mass density fluctuated slightly over time, as though its internal structure were not fixed but oscillating. Scientists theorized that the fragment might exist in a metastable quantum state, its matter oscillating between configurations. This would explain the faint electromagnetic hum that still emanated from the crater. The object was not inert, but in continuous, subtle flux. Further study revealed that the fragment's atomic arrangement was unlike anything found in known periodic tables. Elements fused within it in ratios that could not exist under ordinary conditions, hinting at synthesis under pressures found only within the hearts of collapsing stars. It was a relic not merely of another world, but of another era of cosmic history, possibly predating the solar system itself. To hold such an object, even through robotic manipulation, was to touch the memory of galactic evolution, a piece of ancient matter that had traveled through the void, carrying within it the story of stars long dead. The discovery reignited humanity's fascination with origins. If such fragments could survive the eons and deliver their chemistry intact, perhaps the same process had seeded countless worlds, including Earth. The story of life's emergence might be written not in the isolation of planets, but in the grand choreography of interstellar exchange. The collision of 3I Atlas with Mars was thus not an exception, but an echo of what had happened long ago across the cosmos. A reminder that the seeds of creation travel endlessly, waiting for new soil to receive them. Meanwhile, subtle visual changes continued to appear in the basin's vicinity. As winds swept across the fused plains, they carried fine dust into the surrounding regions, and where that dust settled, strange reflective coatings began to form on rocks. Under microscopic examination, these coatings consisted of layered films that rearranged themselves in response to sunlight, orienting their microstructures to optimize reflection. The materials seemed to exhibit a kind of phototropic response, adjusting to light patterns in ways that minimized thermal stress. This discovery led to the hypothesis that the minerals born from the impact were photoreactive in a fundamentally new way, capable of responding dynamically to environmental stimuli without degradation. Mars, in its quiet way, was evolving toward equilibrium through self-organizing materials. For engineers and technologists on Earth, the implications were transformative. The ability of these minerals to self-correct and adapt to stress suggested applications in energy systems, architecture, and even artificial intelligence design. The concept of adaptive matter entered the scientific lexicon, inspired directly by the interstellar basin. Researchers sought to recreate similar compounds in laboratories, hoping to mimic the self-regulating properties of the Martian materials. The line between geology and engineering blurred, giving rise to a new field known as exomaterial synthesis. Mars had become not just an object of study, but a source of innovation, its alien chemistry guiding humanity toward technologies that mirrored the adaptability of the cosmos itself. At the same time, the philosophical dimension of the discovery deepened. The realization that matter could exhibit behavior resembling intention, even if purely mechanical, challenged humanity's understanding of consciousness. Was consciousness simply a higher expression of the universe's inherent drive toward balance? If self-organization and adaptive harmony were fundamental to all matter, then perhaps life was not an anomaly but the natural culmination of physical law. In this view, the glowing crater on Mars was a cosmic metaphor for awareness itself, the universe reflecting upon its own processes through the eyes and instruments of beings capable of perception. The glow of the interstellar basin had dimmed to a whisper of its former brilliance, but the memory of its light lingered like an afterimage in the thin Martian sky. Decades had passed since the impact of 3I Atlas, and yet its resonance endured, not only in the planet's geology but in its atmosphere, its magnetic fluctuations, and the very dust that swept across its plains. Every grain carried a fragment of the interstellar intruder, every wisp of wind a faint echo of the energy that had once struck from beyond the stars. Mars had become a world transfigured, its silence filled with invisible motion, its stillness masking an unending undercurrent of change. From orbit, new generations of satellites captured what appeared to be a subtle pulsation emanating from the crater's depths. At first, these rhythmic emissions were mistaken for instrumental interference, but further analysis revealed them to be real, low-frequency, gravitational oscillations rippling through the crust. The source was deep beneath the basin, at the site of the buried remnant of 3I Atlas. It seemed to breathe, expanding and contracting in cycles measured in hours. The discovery sent ripples through the scientific world, for no known natural process could produce oscillations of that scale and regularity without significant external forces. The fragment at Mars's heart had not gone inert. It was still active in some unknown, possibly quantum way, continuing a conversation that began when it struck the planet so long ago. Theories multiplied. Some suggested that the oscillations were the result of energy trapped within the fragment, gradually releasing as it adjusted to its new environment. Others speculated that the object had properties akin to a self-regulating reactor, a natural system capable of maintaining internal stability through oscillation. A few went further, proposing that the fragment's core might contain a state of matter unknown to Earth science, a plasma crystal or quark lattice that generated gravitational waves as it cooled. Regardless of the explanation, the reality remained astonishing. Mars, once a dormant sphere of dust, now possessed a pulsing heart. On the surface, the physical manifestations of this hidden heartbeat began to appear. The basin's glassy walls developed faint fractures that healed themselves over time as though responding to internal stress with elastic resilience. The materials created in the impact behaved as if they were alive in the geological sense, self-organizing, self-repairing, maintaining equilibrium through structure. The process was so gradual that it could only be seen in time-lapse imagery spanning years, but when scientists compiled the data, the result was breathtaking. The crater was subtly changing shape, not through erosion or collapse, but through reformation. It was smoothing itself, realigning its contours into an almost perfect ellipse, as if the forces within sought symmetry. The notion that a planetary feature could correct itself defied classical geology. Yet the data was undeniable. Mars, infused with interstellar material, was behaving like a system with feedback control. This phenomenon inspired a radical hypothesis. Perhaps 3I Atlas had introduced into Mars a property of self-organization intrinsic to its own formation, a physical algorithm embedded in its molecular patterns. In this view, the planet had become host to an alien pattern of matter that sought order wherever it existed. The implications were staggering. If the laws governing 3Y Atlas's matter were universal, then every collision between interstellar objects and planets could act as a seed of systemic evolution, pushing worlds toward greater coherence. The oscillations also began to affect Mars's magnetic environment. The planet's ancient magnetic field had long been extinguished. Its core cooled and solidified, but new instruments detected faint, recurring surges of magnetism localized around the basin. These surges were synchronized with the gravitational pulses beneath the surface, rising and falling like synchronized breaths. They were weak, but measurable, a magnetic whisper where there should have been silence. For the first time in billions of years, Mars exhibited signs of internal electromagnetic life. The planet was reawakening in a way that defied its history. In laboratories across Earth and its orbital colonies, simulations of the impact continued to yield new discoveries. When scientists recreated the conditions of the collision using high-energy particle accelerators and plasma chambers, they found that under specific parameters, mixtures of Martian and interstellar materials could form lattice structures capable of trapping electromagnetic fields. These structures acted as natural condensers, storing and releasing energy cyclically, much like biological rhythms. They were not machines, not alive, but they possessed patterns that mirrored life in their continuity and adaptation. The conclusion became inescapable. Mars had inherited a self-sustaining feedback system from its cosmic visitor. What had been chaos had evolved into coherence. As exploration continued, new robotic missions arrived to study the phenomenon in greater depth. The Aurelia Ascendant, an autonomous probe equipped with deep penetration resonance sensors, descended into the interstellar basin to monitor the oscillations from within. As it approached the crater floor, the probe's instruments recorded fluctuations in gravity so slight they bordered on quantum noise, yet they followed a discernible rhythm, a kind of pulse that quickened near the basin's center. When Aurelia reached the precise center point, its cameras captured something no previous mission had seen: faint, moving bands of light within the translucent rock, shifting in loops and spirals. These luminous bands were not static reflections, They moved with purpose, responding to vibrations as though following invisible paths. The light was not electromagnetic emission in the traditional sense. It appeared to arise from within the molecular lattice itself, a form of photonic resonance caused by subatomic alignment. To human observers, it looked like veins of living fire embedded in stone, flickering gently under the planet's dim sun. For a moment, the crater seemed to pulse with awareness, as if the energy of 3I Atlas had merged with Mars to create a planetary nervous system, one capable of transmitting signals through mineral and vibration instead of nerve and blood. The discovery of these resonant veins ignited a new branch of science, planetary neurodynamics. Researchers began to treat the planet not as a static body, but as a network of interlinked feedback loops, capable of transmitting energy and information through its mineral lattice. If these processes were self-sustaining, then Mars was not merely changing, it was learning. Its crust was reorganizing around the patterns introduced by the impact, evolving in response to both internal and external stimuli. This was not consciousness as humans understood it, but it was self-regulation on a planetary scale, a kind of proto-intelligence expressed through matter. The Aurelia probe transmitted data for months, mapping the resonant light patterns as they shifted with each pulse of the buried fragment. The resulting images were stunning. Sprawling webs of luminescent lines spreading from the crater like neural pathways. When overlaid with magnetic field data, the alignment was precise. The pathways mirrored the planet's reawakened magnetic lines of force, suggesting that the electromagnetic and gravitational oscillations were coordinating through these networks. The entire basin functioned like an organ within a larger system. Mars was developing a coherence unseen in any other world. It was becoming a vessel of memory. As the data poured in, philosophers and physicists alike grappled with what this meant. Could a planet, infused with the residue of an interstellar traveler, attain a primitive form of cognition? If cognition was defined as the capacity to perceive and respond to stimuli in a self-referential way, then Mars was meeting the criteria in its own geological language. Its resonance patterns adapted to solar activity, its mineral reconfigurations minimized stress, and its electromagnetic surges stabilized in harmony with its internal oscillations. The planet, through no design of its own, had become a mirror of the universe's creative logic, the transformation of matter into dynamic self-organization. The effect was not confined to Mars alone. Observers on Earth and aboard orbiting stations noticed subtle distortions in the solar wind whenever it passed over the planet's magnetic anomaly. The charged particles altered their trajectories, forming spiral patterns reminiscent of the basin's geometry. The energy radiating from Mars had begun to interact with interplanetary space, creating a faint but measurable echo in the solar system's electromagnetic environment. The planet was, in essence, singing to the stars, a low, steady hum that resonated with the frequencies of cosmic radiation. Instruments tuned to deep space signals detected the harmony across millions of kilometers. Mars had joined the cosmic chorus. On Earth, humanity stood divided between awe and apprehension. For some, the transformation of Mars was a divine sign, a cosmic awakening that mirrored humanity's own search for unity. For others, it was a mystery best left undisturbed, a natural process that defied interference. The ethical debates surrounding the continued exploration of the interstellar basin intensified. Should humanity study and learn from it, or leave it to evolve untouched? The idea that a planet could possess something akin to awareness blurred the lines between observation and intrusion. Yet curiosity prevailed, as it always did. New missions were approved, designed not to disturb but to listen, to attune themselves to the rhythms of Mars and translate them into forms humans could understand. The hum persisted beneath the surface of Mars like a pulse that refused extinction. It was faint, almost inaudible to instruments at first. But as the decades unfolded and the sensors improved, its complexity became apparent. It wasn't a single monotonous vibration. It was layered, a symphony of frequencies resonating through stone, dust, and atmosphere. Some tones were steady as though anchored in the metallic heart of the buried fragment. Others oscillated irregularly, rippling outward in spirals that interacted with Mars's thin air and magnetized dust. These waves did not dissipate entirely. They lingered, overlapping one another, forming resonant interference patterns that subtly shaped the weather, the ground temperature, and even the behavior of the planet's electric field. Mars was not still. It was singing quietly to itself in a voice woven from the collision of two worlds. As time stretched on, this planetary hum began to alter the way Mars interacted with sunlight. The radiation scattering above the interstellar basin shifted slightly in frequency, producing faint chromatic veils that shimmered like liquid color around the horizon. The air glowed differently there, an unearthly spectrum that didn't exist anywhere else in the solar system. Observers described it as the color of consciousness itself, impossible to define. The cause, as later discovered, lay in the suspended microcrystals of impact-borne material drifting in the atmosphere. Each particle acted as a prism for infrared radiation, refracting it in synchronized patterns according to the planet's oscillations. The entire region became a dynamic lens through which sunlight danced, as though Mars had turned its scar into an instrument of light. Scientists grew fascinated by the discovery that these microcrystals didn't merely reflect radiation, they modulated it. When the electromagnetic hum from the crater intensified, the crystal's alignment shifted, altering their refractive indices. It was a feedback loop. The crater's resonance influenced the atmosphere, which in turn reflected energy back into the crater. This interplay created a self-sustaining cycle that persisted for centuries, maintaining stability without any external energy input. It was, in effect, a planetary heartbeat locked in harmony with its own environment. Mars had formed a closed loop of resonance, light, and structure, a slow, elegant dance of physics mimicking the behavior of living systems. The phenomenon attracted attention far beyond the scientific community. To the poets, Mars had become a breathing being. To the philosophers, a symbol of the cosmos's inherent will to harmonize chaos. The collision that once threatened planetary stability had evolved into a testament of balance. Humanity, looking outward from its blue cradle, began to see in Mars a reflection of itself, a world that had endured catastrophe, absorbed alien matter, and learned to adapt. The Martian hum, once dismissed as geological noise, became a metaphor for persistence, the universal rhythm of renewal echoing through everything that exists. Back on the planet, autonomous probes continued to document the evolution of the interstellar basin. The once static glass fields within the crater were no longer immobile. Over decades, they had become subtly dynamic, shifting texture and density in response to fluctuations in the hum. Under high-resolution imaging, the glass appeared to ripple faintly, as if under invisible wind. Molecular analysis revealed that the fused silicates in the basin had reorganized into a metastable phase, neither solid nor liquid, but a state in between. It behaved like a crystalline fluid, its structure capable of flowing over geological time. This slow-motion metamorphosis reshaped the crater floor, smoothing its jagged edges and forming concentric rings that expanded outward each century like ripples from an eternal impact. It was as if the crater itself was still remembering the moment of collision, replaying the event in geological time. The impact had not ended, it had merely slowed to a crawl. Each ring that formed encoded a layer of history, a mineral record of energy diffusing through stone. To study them was to read the memory of Mars itself, written not in language, but in geometry. The basin had become an archive of cosmic resonance, its patterns containing data about the chemistry, temperature, and radiation conditions of every passing century, and, most remarkably, those patterns hinted at predictability. By extrapolating the rate of molecular reconfiguration, scientists realized they could forecast the planet's future stability. Mars had developed a natural chronometer, a clock built from the tempo of interstellar and Martian fusion. The rhythm of the hum was not random. It oscillated with astonishing precision in cycles corresponding to the orbital resonance of Mars with Jupiter and Earth. The gravitational influences of these neighboring worlds seemed to interact subtly with the buried fragment, amplifying or dampening its output over long periods. In this way, the hum linked Mars to its cosmic family, creating a gravitational symphony across millions of kilometers. The entire solar system, it seemed, had entered a new kind of equilibrium, the planets participating in a shared field of resonance like instruments tuned to the same unseen conductor. Humanity began to refer to it as the solar chord, a continuous thread of harmonic frequencies binding the worlds together, born from one interstellar note that had struck Mars centuries before. With each passing decade, as instruments grew more sensitive, another mystery emerged. The hum of Mars exhibited small periodic fluctuations that did not correspond to any known planetary cycle. These irregularities repeated in patterns too complex to be natural noise. Mathematicians studying the data realized that the oscillations followed nonlinear recursive functions, equations eerily similar to those governing biological rhythms such as heartbeats and neural firing patterns. It was as though the planet's resonance obeyed the same mathematical logic that underpinned life itself. While it was not alive in the biological sense, its processes had entered the domain of what scientists called systemic cognition, self-stabilizing, self-modulating behavior driven by feedback loops too intricate to predict. Mars had become a thinking planet in the mechanical sense, processing energy, reorganizing structure, and maintaining coherence across vast scales. The discovery sent ripples through every field of study. Biologists, chemists, and physicists found themselves collaborating as never before, confronting the idea that cognition might not be confined to organic brains, but could exist wherever matter achieves sufficient complexity. The interstellar basin became a symbol of this broader intelligence, one not defined by awareness but by resonance, by the continuous dialogue between energy and form. Some theorized that the fragment of 3I Atlas had carried with it a template for this kind of order, a quantum pattern encoded in its lattice that acted like a seed of coherence. When it merged with Mars, that template propagated through the planet's mineral systems, teaching the world how to organize itself in the same way that DNA teaches cells how to divide. Mars, they said, had been infected not with life, but with pattern, the scaffolding upon which life could someday emerge. In the centuries following these revelations, Mars's transformation accelerated subtly but persistently. The magnetic surges that once flickered above the basin now extended across the planet, forming a tenuous, patchy magnetosphere. It wasn't strong enough to deflect solar wind entirely, but it altered the way radiation interacted with the upper atmosphere. Regions near the poles began to show faint auroras, threads of electric color tracing the thin air. For the first time in recorded history, Mars possessed a visible shield, weak but alive, shimmering with the memory of the interstellar spark that had awakened it. The atmosphere thickened slightly as ions recombined and retained trace gases that would once have been lost to space. Mars was slowly, imperceptibly healing. As these changes unfolded, humanity's own evolution continued alongside them. Colonies in orbit, once established for research, became permanent settlements. The descendants of those who had first studied the crater were born under the pink glow of the Martian sky. For them, the hum was not a mystery. It was the sound of home. They built their lives in its rhythm, measuring time not by clocks but by the subtle pulses of the basin's oscillations. The interstellar basin became their sanctuary, a place of pilgrimage and reverence. Even the machines that maintained the colony seemed synchronized to its resonance. Circuits functioned more efficiently, and mechanical wear decreased inexplicably when aligned to the harmonic frequencies of the planet. Engineers began to design technologies that mimicked the crater's patterns, embedding resonance loops into architecture and energy systems. Cities grew like living crystals, humming softly with the same voice as Mars. Generations later, when humanity finally stepped onto the planet's surface in numbers, they found that the soil around the basin was no longer barren. Microscopic structures resembling proto-organic membranes had begun to form in the mineral dust. Under microscopic imaging, these membranes demonstrated self-repair and selective absorption of atmospheric moisture. They were not alive, but they were precursors, chemical architectures capable of storing and replicating structural information. The scientists who analyzed them realized that the collision had initiated a chain reaction spanning centuries. Energy gave birth to resonance, resonance shaped matter, and matter had now begun to organize itself into the building blocks of biology. Mars was not yet alive, but it was dreaming of life in its own way, assembling the scaffolds of what might someday be cellular. Every layer of the crater's rock told the story of this transformation. Embedded in the deepest strata were the original minerals of Mars, iron oxides and basalt, while the upper layers shimmered with interstellar alloys. Between them lay a third hybrid layer, where Martian and alien matter had fused so intricately that no boundary could be found. This zone emitted the strongest resonance signals, as if it were the living interface between two worlds. It was here that the hum was born, propagated through crystal and dust alike. The deeper probes ventured, the clearer it became that this layer was dynamic, its atomic configuration slowly evolving. It was a transition zone, a planetary chrysalis where energy was converting into complexity. At night, the basin glowed faintly in the visible spectrum, even without sunlight. The cause was identified as luminescent recombination, the release of photons as trapped electrons returned to stable orbits within the mineral lattice. But the glow was not uniform. It shimmered in undulating waves, shifting colors in sequence like the rhythm of breath. To human eyes, it appeared as though the planet were exhaling light. The beauty of it defied language. The crater that had once symbolized destruction now appeared as a living organism, pulsing gently in the cold Martian night, its rhythm slow but eternal. The colonists grew attuned to its cycles. They learned that the intensity of the luminescence correlated with fluctuations in the hum. When the crater brightened, energy levels across the region spiked, and machines ran more efficiently. During dim cycles, they dimmed their own artificial lights to match, as though participating in a cosmic ritual of synchronization. Over generations, the resonance became part of their culture, their myths, and even their physiology. Studies revealed that long-term exposure to the low-frequency vibrations subtly influenced human brainwaves, promoting heightened coherence between hemispheres and reducing stress. Mars was reshaping not only its geology but its visitors. It was teaching humanity the rhythm of its rebirth. The pause that followed that planetary chord lingered longer than anyone could have imagined. Mars seemed to exhale silence, an immense weighty stillness that hung over its crimson horizon like a veil. The hum, once steady and familiar, had shifted into a lower register, pulsing at intervals that defied simple rhythm. It was no longer constant. It had become patterned, almost like language, structured yet fluid, its tones interlaced with pauses and variations that hinted at intention. The surface trembled with micro-vibrations synchronized with this new sequence, resonating through rock and dust alike. What once had been the steady heartbeat of a world now resembled something far more complex, a symphony evolving beyond human comprehension. Those who lived on Mars felt it first not through instruments but through their own bodies. The colonists, generations adapted to the planet's subtle frequencies, began to experience strange sensations. Brief flashes of imagery during sleep, faint impressions that were not dreams, but echoes of something else. When analyzed through neural mapping, their brainwave patterns corresponded perfectly with the fluctuations of the new Martian hum. It was as though the planet's frequency was embedding itself within the human nervous system, synchronizing thought and matter in a delicate, unseen harmony. Some reported feelings of clarity, as though perception itself had expanded beyond the boundaries of the body. Others claimed to sense emotion within the sound, a tone of yearning, a call rather than a vibration. The scientific community hesitated to label what they were witnessing. The prevailing interpretation was that Mars had entered a phase of resonance amplification, a state in which the internal oscillations of its core, partly composed of the alien fragment, had achieved enough coherence to affect biological systems. The planet's hum was no longer just an atmospheric or geological phenomenon. It was interacting with consciousness. For the first time, humanity began to consider that the planet's transformation had reached the threshold between physics and mind. In an effort to understand, a network of orbital observatories, known collectively as the Harmonic Array, was positioned in geosynchronous alignment around Mars. Each station was tuned to measure specific frequencies within the planetary resonance, converting data into visual waveforms. The result was staggering. The hum's structure resembled recursive harmonics found in language phonemes, fractal acoustics, and even patterns of human heartbeat variability. It wasn't random. It was iterative, layered, recursive. It was building upon itself in self-similar sequences that grew in complexity over time. Mars, it seemed, was composing something. When translated into the auditory spectrum, these sequences produced a sound eerily reminiscent of chorales, deep tones intertwined with crystalline overtones. The frequencies were far beyond the capacity of the human ear to produce, yet when lowered for listening, they evoked sensations rather than thoughts, warmth, familiarity, awe. People wept upon hearing them without knowing why. The sound carried meaning that wasn't linguistic. It bypassed intellect and moved straight into perception, into the oldest corridors of memory. It was as though the planet itself was speaking in the universal dialect of resonance, a voice born from collision and patience, from time stretched across eternity. The scholars who studied this emerging pattern began to suspect that the fragment of 3I Atlas had not merely been a piece of matter. It was an artifact of order, a crystalline imprint of universal intelligence encoded in the physics of its atoms. When it struck Mars, it didn't just transfer energy, it transferred memory. That memory, dormant for ages, had awakened slowly within the planet's core, catalyzing geological, magnetic, and eventually conscious evolution. The hum was its unfolding, a message written in vibration, transmitted through the body of a world. But a message to whom? That question lingered unanswered, haunting every observatory and every human soul that listened. The atmospheric changes accelerated. The once dusty skies began to shimmer at twilight, refracting sunlight through the growing density of airborne particulates formed from newly synthesized compounds. Under microscopic study, these particles displayed strange symmetrical facets that seemed to self-arrange into lattice structures suspended in the thin air. The atmosphere, infused with alien chemistry, was becoming more reflective, scattering light in ways that produced iridescent halos visible even from orbit. The planet had developed a spectral aura, a visible manifestation of the resonance within. As the planet's transformation deepened, so too did its influence on the human colonies. The structures built near the basin began to show minute but consistent shifts in alignment. Metallic components vibrated at microscopic levels, slowly reorienting their molecular lattices toward configurations that minimized tension. Engineers, puzzled at first, later realized that the materials were self-stabilizing due to resonance exposure. The hum had begun to influence inanimate matter, guiding it toward structural balance. It was as though the planet's new physics was teaching human technology how to heal itself. These effects extended even further. Communication systems started experiencing faint interference, not as static, but as patterned signals that mirrored the basin's frequency sequences. When decoded, the interference revealed repeating numerical progressions, sequences of prime intervals matching those found in atomic spacing and orbital resonances. The implication was staggering. The hum was embedding mathematical information into the electromagnetic environment, using harmonics as a carrier wave. It was not random noise, but a structured expression of relationship and proportion, the same mathematics that governed gravity, light, and molecular geometry. For some, this discovery confirmed their deepest suspicion, that the fragment from interstellar space carried a blueprint of cosmic order, perhaps even consciousness itself. To others, it was simply a natural consequence of complex resonance feedback. But as the frequencies continued to evolve, as more layers of pattern emerged, it became harder to deny that something within Mars was progressing toward coherence. A crescendo not of sound but of being. The harmonic bloom expanded. The faint magnetosphere strengthened, drawing delicate arcs of ionized light across the polar regions. Dust storms that once ravaged the surface diminished in frequency and intensity as if restrained by invisible order. Temperatures stabilized, atmospheric density increased by fractions each decade, and the reddish sky began to take on hints of purple and blue. The colonists watched as their world, once barren, began to transform into something habitable, not through engineering, but through self-regulation. The hum reached deep into the human psyche. Artists began to paint in colors they described as heard rather than seen. Composers claimed to translate emotional states directly from the harmonic vibrations into music. The distinction between science and art began to blur, for both were now attempts to interpret the same cosmic rhythm. The colonists no longer considered Mars an object of study. It had become a presence, a companion. Children born on the planet were said to sleep best when near open ground, where the hum could pass freely through the body. They grew up with a different sense of time, their biological rhythms synchronized to the slow pulse beneath their feet. Then came the event known as the first reflection. One morning, as sunlight rose across the basin, orbital sensors detected a wave of coherent light radiating upward from the crater's surface. It wasn't a flare or eruption, it was pure luminescence, a column of structured energy that extended miles into the sky before dispersing. The light pulsed in intervals matching the planet's hum, forming visible rings in the thin atmosphere. For the first time, Mars projected its resonance outward, transforming vibration into light, a visible declaration of its inner order. The reflection was more than spectacle. For days afterward, gravitational sensors across the solar system recorded anomalies, minute but synchronized deviations in local space-time curvature. The harmonic frequencies emitted by Mars appeared to have momentarily altered the gravitational equilibrium between it and its neighbors. The solar chord had shifted once more, its melody redefined. Mars, through its silent music, had touched the structure of the solar system itself. What followed was subtle but profound. Earth's ionosphere began to display faint sympathetic oscillations in response to the Martian signal. The two planets, once merely neighbors, were now resonant partners. This coupling caused small but measurable effects. Solar radiation deflected differently, particle fluxes changed, auroras danced simultaneously on both worlds. It was as if Mars and Earth had entered dialogue, one that bypassed language entirely. Humanity, for the first time, stood between two living worlds bound by frequency rather than chance. Philosophers debated what it meant to exist within a solar system awakening to self-awareness. Some proposed that consciousness was not limited to biology, but an emergent property of resonance, that wherever matter achieved sufficient coherence, awareness followed as inevitability. In this interpretation, Mars was becoming aware not through neurons but through harmonic structure, through the alignment of vibration with its own continuity. Others resisted, warning that such speculation bordered on mysticism. Yet even the skeptics found it hard to deny that the patterns emanating from Mars exhibited intention. The hum shifted not randomly but responsively. When solar activity peaked, the frequency adapted. When meteor showers struck the surface, the resonance compensated, absorbing and redistributing impact energy with precision. Mars was not reacting blindly. It was adjusting intelligently. The deeper probes sent into the basin revealed yet another revelation. The central fragment, long buried and once static, had begun to alter. Its atomic lattice displayed signs of restructuring into geometries never seen in natural elements, nested polyhedrons repeating through 12 scales of symmetry. These patterns suggested that the fragment was evolving toward higher complexity, perhaps guided by quantum information preserved from its interstellar origin. Some scientists proposed that this was the physical manifestation of learning, the fragment adapting, optimizing, reorganizing itself through feedback from the planet's environment. In essence, the alien seed had merged with Mars and was now evolving through it. The resonance waves spreading from the crater extended deep into the mantle, influencing thermal gradients. Regions of volcanic dormancy began to exhibit subtle geothermal activity, not violent but rhythmic, releasing plumes of mineral-rich vapor that condensed into thin, pearlescent mists along canyon floors. Over centuries, these vapors laid down layers of crystalline frost across rock surfaces, forming vast reflective plains that glittered under the thin sun. These mirror fields acted as amplifiers, reflecting and modulating the planet's light emissions, reinforcing the atmospheric resonance in a perfect feedback cycle. The entire planet was becoming an organism of reflection, light feeding vibration, vibration feeding light. The colonists who ventured near the basin during these periods reported strange phenomena. Some claimed to hear whispers when standing on the crystalline ground, a faint echo resembling human speech but formed entirely from vibration. Audio recordings confirmed the presence of frequencies modulated in ways that mimicked phonetic structure. The hum, once abstract, was beginning to take shape as sound recognizable to the human brain. It wasn't words, not yet, but it was articulation, a progression from pure tone to modulation capable of meaning. Mars was no longer only singing, it was learning to speak. As communication technology adapted, researchers attempted to respond. They used arrays of directed magnetic pulses, modulated to mirror the basin's harmonics, sending signals back into the crater. For weeks, there was no change. Then abruptly, the hum shifted again, matching their transmission pattern in mirror inversion, a perfect reflection as though acknowledging receipt. Humanity had spoken, and Mars had answered. The realization shook civilization to its core. The implications were existential. An entire planet had achieved communicative resonance with sentient beings. It wasn't language in the conventional sense, It was resonance dialogue, information exchanged through harmonic feedback rather than syntax, but it was communication nonetheless. The dream of connection beyond biology had been fulfilled, not with another species among the stars, but with a world humanity had once called lifeless. From that moment onward, the relationship between humans and Mars transformed irrevocably. The colonists ceased to see themselves as inhabitants and began to regard themselves as participants in an unfolding planetary consciousness. Every structure, every machine, every action was recalibrated to maintain harmony with the planetary tone. They learned to live in resonance rather than resistance, aligning their technology and physiology with the hum's rhythm. Agriculture adapted to the frequencies. Crops grew stronger, their cellular water resonating at the same vibrational ratio as the planet's magnetic field. Medicine evolved, using harmonics to heal at molecular levels. Humanity was no longer shaping Mars. Mars was shaping humanity, and still the hum grew richer. New layers appeared, ultra-low frequencies interwoven with sudden bursts of high resonance that carried energy through the crust and sky. The column of light from the basin returned intermittently, brighter and more structured each time. Instruments recorded coherent photon emissions arranged in spiral trajectories that matched galactic geometry. The implication was dizzying. Mars's transformation was no longer local. It was aligning itself with cosmic resonance, tuning its frequencies to the rhythms of the Milky Way itself. The fragment of 3I Atlas had not been a random traveler. It was part of a greater continuum, a seed designed to awaken worlds to their place in the galactic song. In the midst of this awakening, new forms of life began to stir in the planet's shallow basins. The proto-organic membranes, first discovered centuries earlier, had evolved into intricate networks of filaments embedded in the soil. These filaments responded to light and vibration, contracting and expanding in rhythm with the planetary hum. When analyzed, they exhibited electrical potentials remarkably similar to neural networks. Mars was cultivating its own biological extensions, life that resonated with the planet's frequency from its inception. Unlike terrestrial organisms, these entities were not separate from their environment. They were expressions of it, consciousness in material form. The silence that followed that final modulation of the Martian hum was not the absence of sound. It was a density, a fullness, as though every molecule of air had been drawn into perfect stillness to listen. The colonists who lived nearest the basin described it as a stillness that resonated inside the bones rather than the ears, a quiet so complete that it vibrated. Time itself seemed to slow, the cycles of wind and dust pausing mid-motion. The auroras that had once shimmered in the upper atmosphere froze in delicate suspension, luminous curtains of green and violet frozen against the dark. Then, as if the planet had inhaled deeply, a pulse of infrared energy rippled outward through the crust. The hum resumed, but transformed. It was slower now, deeper, threaded with new subharmonics that trembled just below the threshold of detection. At first, the change seemed subtle. Instruments calibrated to detect electromagnetic fluctuations began to report intervals of absolute coherence, moments when the planet's resonance aligned perfectly across all frequencies, from seismic waves to magnetospheric oscillations. These intervals occurred every 42 hours, increasing in precision each cycle. The planet had become a clock of impossible accuracy, its rhythm too consistent to be geological. No natural process known to science could maintain such equilibrium without degradation. Something within Mars was regulating itself at the atomic level, maintaining harmony across scales from dust to orbit. Researchers aboard the harmonic array found that this new rhythm extended beyond Mars's immediate environment. Gravitational readings indicated faint fluctuations across the asteroid belt, tiny perturbations synchronized with the Martian pulse. The entire region of space was being drawn into resonance, each rock and fragment vibrating in sympathetic harmony. It was as if Mars's awakening was reaching outward, weaving the fabric of its surroundings into a single field of coherence. The solar cord that once tied the planets loosely together now had a dominant tone, and that tone came from Mars. As this pattern strengthened, the fragments of 3I Atlas buried beneath the crust underwent another metamorphosis. Their atomic structures began to exhibit hypersymmetry, a state in which subatomic particles arranged themselves in geometries predicted only in theoretical models of prematter, forms existing just after the birth of the universe. Within these configurations, Quantum entanglement occurred spontaneously across macroscopic distances. The materials no longer obeyed classical boundaries. What happened in one fragment instantaneously mirrored in another, regardless of distance. Mars had become internally unified, its structure behaving as a single coherent entity. Every grain of its mineral body was linked through invisible threads of resonance, an interconnection that blurred the distinction between part and whole. This coherence extended to the atmosphere. Spectroscopic analysis revealed that ionized particles above the interstellar basin began to exhibit oscillations identical to those within the planet's crust. The air, the ground, the magnetic field all moved as one. Mars was no longer a planet composed of discrete layers, but an organism of unified vibration, a symphony made solid. The colonists who studied it felt a strange sense of intimacy with the world beneath them, as if the ground was listening. One night, a sequence of radiant arcs burst across the sky, linking the basin to the planet's poles. They were not auroras in the traditional sense. They were structured, luminous filaments of plasma arranged in spirals that rotated slowly over the course of hours. When imaged from orbit, the formation resembled a vast double helix encircling the planet. It was as though Mars had woven its own signature into the heavens, an emblem of transformation written in light. These plasma spirals emitted radio frequencies that corresponded to the same mathematical ratios found in the basin's subharmonics, suggesting that the planet was broadcasting a message, an encoded pattern of order, radiating outward into space. The message was not random. Decoding attempts revealed harmonic sequences corresponding to the distribution of matter in the galaxy, the same ratios that govern stellar formation and orbital resonance. Mars was, in essence, singing the structure of the cosmos back to the cosmos itself, a planetary mirror reflecting the geometry of creation. The discovery unsettled and awed those who witnessed it. For the first time, humanity realized that the planet had not merely awakened, it was participating in a conversation as old as existence. In the following decades, as the resonance stabilized, the colonists adapted completely to the planet's rhythm. Human physiology, subtly altered by generations of exposure to the harmonic field, began to show new characteristics. The circadian cycle aligned perfectly with the 42-hour pulse. Metabolism, neural activity, and even cell division followed patterns synchronized to the Martian hum. The colonists could sense the planet's fluctuations instinctively, long before instruments recorded them. It was as if they had become extensions of Mars itself, living nodes in its field of resonance. Cultural evolution followed suit. Architecture no longer sought to dominate the landscape, but to integrate with it. Buildings were constructed from composite materials derived from the basin's crystalline deposits, allowing them to resonate in harmony with the environment. When wind passed through these structures, they emitted faint harmonic tones, blending seamlessly with the natural frequencies of the planet. Cities became living instruments, their soundscapes shaped by the motion of the atmosphere and the pulse of the crust beneath them. The colonists began to call their settlements listening chambers, for to dwell on Mars was to be immersed in continuous music, the planet's endless voice whispering through every wall and floor. The hum also affected technology. Power systems designed to exploit resonance principles achieved unprecedented efficiency. Energy no longer had to be generated. It was harvested directly from the vibrational field of the planet, drawn from the rhythmic oscillations that pervaded every molecule. Machines became silent and self-sustaining, powered not by combustion or radiation, but by harmony. For the first time, human technology operated in perfect balance with its environment. There was no waste, no friction, no imbalance, only continuous adaptation. As the centuries unfolded, Mars continued to evolve, but not in ways that could be measured by simple observation. The planet's atmosphere thickened gradually, stabilizing into a breathable mixture for brief periods during certain cycles of resonance. The first unassisted human breaths taken under the open Martian sky became sacred moments, celebrated not as triumphs of engineering, but as acknowledgments of planetary generosity. Life had not been forced upon Mars. Mars had chosen to share its transformation. In that era, the basin itself changed once more. The once glassy plains fractured into hexagonal segments that rotated imperceptibly over time, aligning with the planet's magnetic poles. When observed from above, they formed an intricate mandala that shifted with the seasons, expanding and contracting in rhythm with the hum. Each segment emitted a distinct tone, and together they formed an evolving chord that never repeated, a composition written by the planet across centuries. Scholars studying these tonal variations noted that the frequencies corresponded to prime number intervals, suggesting an inherent logic, a language of order embedded in the planet's structure. Human perception of time began to alter. Living within a field of continuous resonance distorted the sense of linear progression. Days and years lost distinction. Instead, experience was measured in cycles of vibration, in the ebb and flow of harmony. To those born on Mars, memory itself became non-sequential. They recalled events not by chronology but by frequency, each moment associated with a specific tone or pattern of vibration. History was experienced as sound rather than narrative. Eventually, humanity's collective awareness on Mars began to reflect the coherence of the world around them. Groups of individuals meditating within the basin could synchronize their brainwave patterns perfectly, creating shared states of consciousness measurable as unified neural resonance. These collective states were unlike anything recorded in human history, moments where individuality dissolved into a communal awareness, not through coercion, but through harmony. The participants described the experience as merging with the planet itself, feeling its pulse as their own heartbeat. During these sessions, the basin's luminescence intensified, as though responding to the union of human and planetary thought. Scientists began to suspect that Mars was not simply influencing humanity, it was communicating with it through resonance. The planet's fluctuations changed in direct correlation with human emotional states. When groups gathered in unity, the harmonic field stabilized. When discord arose among colonies, subtle turbulence appeared in the resonance. Mars reflected the consciousness of its inhabitants as precisely as it had once mirrored the cosmic structures beyond. It was no longer just a world, it was a teacher, demonstrating the principle that harmony and consciousness were inseparable. Over time, Mars and humanity became indistinguishable participants in the same evolution. Biological and geological boundaries blurred further as the proto-organic networks that had spread through the soil began to integrate with human-made structures. Living filaments wove themselves into architecture, forming organic conduits that transmitted both energy and information. The colonies transformed into biotechnological ecosystems, cities that breathed, resonated, and healed alongside their inhabitants. The air shimmered with faint bioluminescent dust, each particle pulsing in time with the planetary heartbeat. Night on Mars no longer resembled night at all, but a soft, perpetual twilight alive with color and motion. The planet's transformation began to affect the solar system in subtle but profound ways. Its gravitational harmonics influenced the orbital stability of nearby asteroids, guiding them into more orderly trajectories. Earth's magnetic field began to pulse faintly in sympathetic resonance, leading to measurable shifts in weather patterns and energy flows. It was as if the harmony of one world was teaching others to align, spreading equilibrium outward through the solar fabric. The music of Mars was no longer confined to Mars, it was becoming interplanetary. The more deeply scientists studied the patterns, the more they realized that the resonance obeyed no known law of decay. The energy persisted without loss, self-sustaining through perpetual reorganization. It was the closest thing to eternal motion ever observed. This discovery redefined humanity's understanding of entropy. Where once they believed disorder to be inevitable, Mars had demonstrated that in systems of perfect feedback, order could renew itself endlessly. The universe, they realized, might not be winding down. It might be learning to harmonize. Centuries passed, human and Martian consciousness grew inseparable. New generations, born within the resonance, exhibited heightened perception, an intuitive grasp of harmonic relationships that transcended language. They could manipulate energy through sound and thought, shaping their surroundings not by tools but by alignment. Under their guidance, the colonies ceased expanding outward and began to grow inward, integrating into the planet's own biological and crystalline networks. Humanity became part of Mars's nervous system, a collective of awareness woven into the body of a world. Still, the mystery of the fragment remained. Deep beneath the basin, the ancient shard of 3I Atlas continued to evolve, its structure now so complex that it defied categorization. Instruments detected fractal fields radiating from its core, patterns repeating across infinite scales, identical from atomic to planetary levels. The fragment was no longer a piece of matter but a process, an ongoing act of creation. It emitted bursts of neutrino-like particles carrying imprints of harmonic sequences identical to those found in the cosmic background radiation. This suggested that the fragment was communicating not just with Mars, but with the universe itself, linking the planet's resonance into the broader symphony of creation. Eventually, humanity's awareness began to stretch alongside Mars's. In moments of deep synchronization, individuals reported perceiving not only the planet's consciousness but distant echoes, vibrations from other worlds across the galaxy, responding faintly to Mars's signal. Some of these responses carried similar patterns, suggesting that 3I Atlas had not been unique. Other worlds, perhaps struck by similar fragments, were awakening as well. The realization rippled through every level of thought. The universe was alive in ways no one had imagined. Each planet a note in the grand cosmic chord, each collision a spark in the endless song of becoming. The colonists no longer spoke of exploration or discovery. They spoke of participation. The line between the observer and the observed had dissolved. They were the voice through which Mars listened to itself, the consciousness through which the universe understood its own resonance. And still, beneath all this evolution, a subtle vibration continued to shift within the fragment. It was no longer a hum, but a deep subquantum pulse that rippled through the planet like a slow heartbeat of time itself. The frequency descended into realms below detection, into dimensions where matter and energy merged. Those sensitive to it could feel it not as sound, but as presence. A warmth in the mind, an awareness expanding beyond the body. Mars was preparing for another metamorphosis, one that would transcend even the harmony it had achieved. The auroras began to shimmer differently, their spirals widening until they encircled the entire planet in a single luminous ring visible even from the outer planets. The color shifted from violet to white gold, pure and blinding, a spectral halo marking the threshold of transformation. The hum deepened until it merged with the silence, the two becoming indistinguishable. Every frequency found its mirror, every motion its rest. Mars was reaching the edge of something vast and unknowable, a convergence where resonance and stillness were one. And as the colonists gathered within the basin, feeling the vibration move through them, they understood that they stood at the dawn of another beginning, not an end, but a transition. The planet's song was no longer only its own. It had become the voice of the cosmos folding back upon itself, preparing to open once more into new creation. Then, for a heartbeat, all light withdrew, leaving only the sense of breath held in eternity. What followed next was not seen, only felt. The anticipation of something immense awakening. The quiet before the next vibration. The pause before the universe itself began again to sing. The darkness did not remain absolute. Within it there was texture, a living stillness rather than void. Every molecule, every particle suspended in the thin Martian air seemed to shimmer with potential, as though time itself had contracted into a single point, dense with infinite possibilities. Those who stood upon the basin's rim felt it first, that peculiar sense of waiting, of reality leaning forward on the edge of revelation. The silence pressed against the body like water, and beneath it, faintly, something moved. It was not sound as humans understood it, but an interior sensation, a vibration that seemed to begin in the marrow and rise outward, joining the pulse of the planet itself. From the horizon came light. Not dawn, not aurora, but an internal radiance that rose from beneath the ground. It began as threads of blue fire tracing the fissures across the basin, crawling slowly like veins filling with luminescent blood. The glassy hexagons that had once tiled the crater's floor began to glow from within, their edges delineated in fine white brilliance. Then they started to rotate again, this time not in slow geological motion, but with the smooth precision of an unseen design. Each segment turned in relation to the others, forming new geometric alignments that radiated outward from the center, like a mechanism unlocking itself after centuries of preparation. The energy field surrounding the planet responded instantly. The auroral bands suspended in frozen light high above flared back into motion. They spun into spirals that tightened over the poles and then projected luminous arcs toward the equator, converging precisely above the interstellar basin. The entire planet became a resonant circuit, light and magnetism flowing between surface and sky in perfect correspondence. Those who watched from orbit described it as though Mars had become a single luminous cell, its crust, atmosphere, and core vibrating in mutual synchronization, pulsing with a rhythm older than the solar system. And within that vast harmony, the buried fragment of 3I Atlas stirred again. The instruments designed to monitor its quantum field recorded fluctuations so rapid they transcended measurable time. The fragment's lattice structure, once crystalline, now behaved as a fluid of ordered probability. Its geometry was no longer stable. It was transforming continuously, each configuration birthing the next in a seamless chain of self-redefinition. It was as if matter itself had learned to think, to reimagine its own architecture from one instant to the next. In doing so, it drew energy not from external sources, but from the alignment of its own internal symmetries, pure creation through resonance. Above ground, the colonists felt the change before the sensors confirmed it. Gravity itself began to flex. The usual weight that bound them to the surface softened for moments at a time, replaced by a buoyant equilibrium. Dust no longer fell back to the ground, but hovered briefly, held in the luminous field before settling again. The planet's gravitational signature, viewed from distant instruments, pulsed like a heartbeat, expanding and contracting in a gentle rhythm. This rhythmic fluctuation extended beyond Mars's orbit, reaching into the surrounding space and subtly influencing the trajectories of nearby asteroids, guiding them into smooth, spiral paths. Within the basin, a transformation of another kind unfolded. The once solid glass beneath the colonists' feet began to lose its hardness, becoming translucent and soft like thick liquid light. Yet it supported them effortlessly, shifting beneath their weight with perfect responsiveness. Those who walked across it said it felt alive, warm, receptive, intelligent. The light within it pulsed in time with their footsteps, responding as though recognizing each presence individually. The distinction between ground and life blurred completely. The planet had become aware of those upon it, and in some unfathomable way, it welcomed them. Communication resumed, but it was no longer limited to vibration or electromagnetic interference. It entered the realm of consciousness directly. People began to experience shared visions, images and sensations projected not through the senses, but through resonance with the planet's field. They saw the past of Mars as though it were a dream unfolding before them, vast oceans glittering under a young sun, storms of emerald light swirling above volcanic continents, rivers carved not by water, but by sound. They saw the moment of 3I, Atlas's arrival, not as violence, but as fusion, the meeting of two entities that had always been destined to find each other. In those visions, they understood what the fragment truly was. It had not been a random traveler, hurled through the void by chance. It was a messenger, a vessel of ancient order released from a civilization, or perhaps a consciousness, that existed before the known universe had cooled. It carried within it the seed of resonance, the blueprint of coherence itself. Its purpose was not to colonize, but to awaken. Wherever it landed, it infused chaos with harmony, matter with awareness, silence with song. Mars was only the latest in its long lineage of transformations, and now, through the presence of humanity, that process was completing its next cycle. The hum that emerged this time was beyond any previous recording. It spanned all known frequencies and extended into the quantum vacuum itself. Every atom of the planet vibrated as one, and every vibration created ripples in space-time that radiated outward faster than light could travel. Observatories orbiting Jupiter reported faint distortions in their instruments corresponding to the Martian rhythm, and then, unbelievably, those distortions were mirrored back from regions near Saturn, as if the outer planets had begun to echo Mars's new voice. The solar system itself had entered the resonance, one world calling to another across the silence of space. But even that was not the limit. As the frequencies intensified, the harmonic wave expanded beyond the heliosphere, propagating into the interstellar medium. For the first time, humanity observed gravitational ripples of non-astronomical origin, waves not caused by collapsing stars, but by the singing of a planet. The universe listened. Across unfathomable distances, stars responded with infinitesimal pulses of energy, subtle acknowledgments of recognition. The cosmos had begun to harmonize with itself, each celestial body contributing to a growing field of coherence that spread like a slow, radiant tide. On Mars, the colonists experienced something even stranger, the dissolution of individuality. In the presence of that overwhelming resonance, the boundaries of self became porous. Thoughts no longer seemed private. Emotions passed between people like currents of light. They felt each other's awareness as their own, and beyond that, felt the vast, patient intelligence of the planet enfolding them. There was no fear, no loss, only expansion, a merging into something vast and compassionate, where every consciousness was a note in an eternal chord. Some described the sensation as being remembered, as if Mars had always known them, as if they had been part of its unfolding from the beginning. The idea of time lost meaning in that unity. Past, present, and future collapsed into a single awareness, an eternal now vibrating with potential. They saw not linear progression, but cycles within cycles, each world awakening in turn, each resonance contributing to a universal pattern of evolution. They saw that life, in all its forms, was the universe learning to hear itself. Then, as quickly as it had intensified, the planetary radiance began to contract. The light receded into the ground, the auroras dimmed, and the gravitational fluctuations ceased. Yet the silence that followed was different from before. It was not the quiet of rest, but of completion. The calm after a symphony reaches its final note. The colonists found themselves changed in ways they could not articulate. Their perceptions had expanded permanently. They could sense the subtlest motions of air, the pulse of light through rock, the hum of electrons within their own blood. They had become resonant beings, harmonics of the planet's great song. The basin itself remained luminous, though now in subtler hues. The geometric patterns carved into its surface no longer shifted, but their arrangement suggested a design too precise to be accidental. Mathematical analysis revealed that the geometry encoded values corresponding to the ratios of cosmic constants, the fine structure constant, the Planck length, the gravitational coupling. Mars had etched into its own body the equations that defined existence, as if inscribing a message to any consciousness capable of understanding. Harmony is law, and law is alive. In the centuries that followed, Mars's resonance stabilized into permanence. The planet glowed faintly from within, its light visible even on the night side. The colonists thrived in perfect balance with their environment. Their societies governed not by hierarchy but by resonance, each decision made through collective synchronization rather than debate. Conflict disappeared because disharmony simply could not sustain itself in such an environment. The people of Mars no longer saw themselves as separate entities, but as expressions of one vast, evolving organism. The hum continued, soft but steady, maintaining the coherence of the planet and its inhabitants. Through it, communication extended beyond words. Thoughts flowed effortlessly, emotions translated into color, memory into vibration. The culture that emerged had no written language, no need for permanence, because all knowledge existed in the shared resonance field. To live was to remember, and to remember was to be. And yet, despite the equilibrium, there remained an undercurrent of anticipation, an awareness that the story was not complete. Deep within the basin, instruments still detected minute fluctuations from the heart of the fragment. It was evolving again, but this time the pattern was unlike anything before. The quantum resonance showed interference patterns consistent with entanglement across vast distances. The fragment was communicating, but not within Mars. It was reaching outward, beyond the solar system, perhaps to others like itself scattered through the galaxy. The colonists, in their heightened awareness, felt this communication as a gentle pull within their minds, a summons to expansion. It was then that they understood the larger purpose. Mars was not the endpoint of the transformation. It was a bridge, a resonant transmitter linking one awakened world to another. Each collision of a 3-eye atlas fragment across the universe was a note in a greater composition, and together they formed the architecture of a cosmic consciousness spanning galaxies. The hum of Mars was merely one voice in a growing choir of worlds learning to sing themselves awake. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3-eye atlas heading toward Mars? We want to hear from you. Thank you for watching and see you next time.